Hey everybody, thanks so much for joining us tonight for the last webcast of 2022, the ECM, Engine Control Module or Emissions Control Module. Of course, here we are once again at Mr. Trulia's shop up in Mahopac. We have the lovely Miss Doreen working on the camera behind us there. And before we get to introducing some of these other faces, let me first just say thanks to the people that made tonight possible. That's the folks at Delphi, part of the Borg Warner family. When you're looking at engine management controls for your vehicle, go with Delphi. The OEs do. And as another benefit, we have with us a special guest instructor, Mr. Dave Hobbs. Dave, thanks so much for joining us here.
Thank you.
Dave, thanks for coming up.
Yeah, appreciate everybody for watching, registering, getting onto this webinar tonight, watching it later, whatever the case may be. And I'm ready to rock and roll and have some fun with my buddies here in the shop in Mahopac, New York.
Yeah, and that's why I want to kind of leading up to the long way around is our good friend, my mentor, my partner in crime,
the guy behind the mask.
The guy behind the mask, Mr. Trulia, feeling a little under the weather. So he's going to
weather tonight, so I'm going to let them do most of the yakking. I will interject, stay out of the picture. But you have a great webinar coming up. I do want to thank Delphi myself, and of course for Pete coming up. And before I forget, a happy Thanksgiving to you and your family, and Merry Christmas, Happy Hanukkah, Happy Kwanzaa, and Happy New Year until we see you in the new year.
Yeah, until we see you in 2023.
Yeah, almost over. Another month.
And Dave, thank you for coming out as well. And I'm going to get out of your hair and do the chat work. I don't want to get anyone. My sore throat is pretty nasty. So
yeah,
I'll leave it up to you two guys to kick butt, and I'll interject from here to there.
We appreciate
Thank
it.
you.
Thank you, G.
All right, G.
All right.
All right. So before we get started, as always, a few things to cover so that you can get the most out of tonight's webcast. There is a chat function, of course, on the play page. We encourage you to ask your questions, offer your insights on that chat function. But as we've also mentioned in the past, let's keep it clean, guys. Every now and then we have someone who misuses that function. We don't want to block you or keep you from participating. So let's all be big boys and girls and use tonight for what it's supposed to be. And that's to help us all become a little bit better than we were before we got here, okay? Number two, if you go, first on the play page, if you look at the top, you're actually going to see two links on the play page. The first one is for the handout tonight. It's a copy of the presentation. If you haven't already, I would encourage you to download that, take some notes. If you can't download it right now, maybe you're watching on your phone or at the shop or whatever the case might be, grab a piece of paper, pencil, take some notes. We have got a lot of great information for you tonight, and you probably want to make sure you jot that down so you can keep that in mind. Hey, if this is your first time at one of our webcasts, well, you've set up now an account with Motor Age Training. When we're done with tonight's webinar, make sure that you take a look around at all of the library of stuff that you have to view and take advantage of. Every webinar that Mr. Trulia and I have done over the past 12 years is on that platform. Most of that material is available to you at no cost. So please make sure that you take advantage of all of that. All right. All right. And of course, if you have any questions now or later, here are the addresses for everyone. And we'll pull that up on the screen. There we go for everybody. Take a snapshot of that with your camera, screenshot, however you want to jot that information down. And, you know, G and I have said this many, many times, knowing Dave for many, many years now as well. I know he feels just as strongly about this as we do. It's just all for one reason, guys and gals. We want to help you have a better living, better life than we did in a business that can certainly reward you if you keep your skill sets up to date. So that's anything we can do to help you, all three of us, whether it's related directly to tonight's topic, or maybe there's some other question. Maybe you got some other question related to drivability or Delphi product lines or the technologies that they're involved with. You know, they're getting big into the hybrid market and EV as well. Dave's an expert in that area. Take advantage of your resources. That's how you get to be a better tech, right?
Yeah, there's enough frustrations just with the technology changes. We don't need to add anything to that, such as, well, I'm too prideful to pick up a book and learn or to look on the internet. Use all those resources. So as Pete was talking about, 12 years worth of these webinars. That's a wealth of resources right there. So after you watch this one, watch the pick whatever title looks like it interests you and take a look for more than 5 minutes. Chances are you're going to either review a few things you've forgotten if you're an older tech, or learn a bunch of new stuff, old or new technician in the market. Make sure you get that resource and utilize it.
Absolutely.
We
Absolutely.
want to remind everyone they could type their questions in the chat box.
Right. Okay, so again, if you have any questions, just use that chat box to type your questions in. Okay. Oh, they're telling me move over, move over.
Okay.
Is that better?
No, here.
Oh, come here.
Just a quick second.
Come here.
The chat function, getting it up there. It says activate. So as we're waiting, we do have a bunch of stuff. It is no such thing as a bad question, only one you don't ask.
Right.
So ask the questions, and
There you go.
between the three of us,
As they
Use
say
this one.
in the training business,
Okay, so
there's
you're
no
right.
dumb
Okay.
questions.
All right.
Only
Okay.
folks that need to ask what you might be embarrassed asking. Don't be embarrassed.
So there we go again. It's that's why we always do these live. There's always little things that we have to take care of behind the scenes, but now we can make sure we keep up with you guys on the chat functions. All right. Hey, tonight this is what we're going to talk about. We're going to talk about the ECM's primary role. Like you said, the title for the webinar was ECM, Engine Control Module or Emissions Control Module. So we want to talk about that. We're going to talk about how the ECM monitors its systems and why, when you're making any engine management related repair, whether it's just a drivability, no code complaint, or it's a DTC that's turned the mill on, who's your real customer when you need to take care of that repair? And understanding while those tests can be used to your advantage and design tests of your own. I don't know about you, Dave, but I'm not a real fan of flow charts. I use them for resources, but I don't use them as my go-to
I
tool.
use them if I know nothing about the system and there's insufficient theory of operation and a really horrible schematic. I might use them. But I know from working with engineers who have developed those flow charts, they're very difficult to develop because you can't predict every failure. And you certainly can't predict what each technician will have access to, both knowledge and skill set and tools. So for
Right.
years, we didn't even have anything about a scope in a flow chart. But, finally, scopes got to be more accepted in the OEM circles, and there's where flow charts come from. It's not like the aftermarket really developed flow charts.
Right.
It's the OEMs developed the flow charts. So they do
Absolutely.
their best, but it falls short for a lot of real
Yep.
reasons. There's nothing wrong with the vehicle as far as the serviceability or the service engineers that develop flow charts. It's the complexity. It's the whole big picture. And that's where we need the theory of operation and some things we're going to talk about tonight, which will be, some of you might think is review or fundamental, and others will go, you know what, I need to brush up on that. And there'll be some new angles of how we go about engine management discussion this evening that's way new, maybe something you've never seen before.
Yeah, and that's something that you've heard. If you've been here before, you know that's something that Jay and I have harped on and continue to harp on. The vehicles that you guys and gals are working on today are the most highly complex, highly technical marvels of engineering that the automakers have ever produced. Well, back when we started off, you could be a little bit off with the point gap and the engine would still run. Today, there's no gray area anymore. You either fixed it right or you fixed it wrong. How are you going to know? We'll give you some tips on that, all right? We'll talk about tools of the trade, how to use them to help you isolate problems related to the ECM. We'll look at global OBD2. We're going to look at the scope and some accessories that go with the scope. If you guys are scope users, let me just ask you this. If you're a scope guy, type an S into the chat box for me. And if you are new to scopes or haven't used a scope before, type an N in there for newbie. So we have kind of a feel for how many of you guys have some experience in that and who doesn't. I'm going to tell you right now, I personally feel that there are many systems on the vehicle you are just not going to fix without a scope. And the other thing I like about using the scope is there's so many tests that I can do more efficiently, more quickly, more accurately with my scope than you can using traditional methods. And we're going to talk about that. So if you don't use a scope, I'm going to encourage you, when you go back to work tomorrow, take a look at your shop scan tool. If you've got a big box tool like the Snap-on or the Autel or the Launch or any of these big box aftermarket tools, they come with scope modules. Yeah. And I've seen more than once where the leads are still in the original wrapper, has never been taken out of the box. So you may find that you have that very valuable tool already in your shop. And if you continue having an interest in using that tool, yeah, we're going to kind of tease you with it in some examples tonight. But again, you have our email addresses. You reach out to us. We'll point you to all the resources you can handle on how to learn and master that tool.
You know, Pete, I'll throw in there, they have to remember a scan tool is only about 10 to 15 times a second update rate.
Yeah.
Yes.
A meter is 40 times. A scope over 25 million samples.
Yeah, and as G was pointing out, if you couldn't hear what he had to say, again, when you're looking at the data on your scan tool, has a very slow refresh rate. So if you're trying to graph data, it's not going to catch all the little glitches and so forth. If you use a multimeter to perform some of your tests, that's a little bit faster. Nothing beats the scope for speed.
It's real time.
Yeah, real time.
Called dynamic.
And we are going to kind of focus on fuel towards the end of our discussion because, and you'll see why as we go through the opening of our presentation. All right, let's start with this. Emissions control module is a more appropriate term for that little black or silver box that runs the engine.
I still like to call them FREDs.
FREDs,
Frustrating,
yes.
ridiculous electronic devices. But ECM, PCM, whatever, ECU, engine control ECU, it's all about protecting the catalytic converter.
Yes, and in fact, if I remember the standards correctly, and you're a lot more in tune with that than I am, Dave, the only thing that can cause that check engine light to come on is any condition that the ECM detects would cause the vehicle to exceed the federal test procedures that it originally met by a certain level. I think it's 1.5 times.
Yep.
So yes, we know that there's the EVAP system as part of the emission controls that the engine control module takes care of. But as you mentioned, for management of the engine, the actual running of the engine, primary job is to keep that little guy happy.
And it's E10 or E15. It's not ethanol, okay? Not a diesel. It's gas engine running normal fuel. We're talking stoichiometric is typically where the catalytic converter likes to work. It can work a little richer or a little leaner, but it tends to take care of the NOx, the unburned fuel, the hydrocarbons, the carbon monoxide, the three biggies, the three evil ones, beyond carbon dioxide, things like that. The best at that stoichiometric ratio, and anything that gets way above that or way below it can affect that 1.5 times the legal emissions that the government came up with way when you and I were learning computers about. Well, Fred is on his 40th birthday, I think.
Yeah, right, for sure.
1980 and 42nd birthday, 2022 this year. So it's all about getting that stoichiometric mixture, which happens to be around 14.7 pounds of air to 1 pound of fuel. It's not a ratio of parts, it's weight. And 1 pound of fuel, you know about what that is. That's like a liter bottle of water. And 1 pound of air, that's going to be hundreds of gallons volume-wise of air for 1 pound, because air is very light. So that's what it's all about, getting that stoichiometric ratio, keeping that catalytic converter functional and not poisoned with engine management.
Right. And as Dave pointed out, it's like I'm talking to he's over there. But as David was pointing out, that range, I think I read this in the Bosch Automotive Handbook, that the ideal range for the catalytic converter, when we talk about lambda, guys and gals, that's that perfect air fuel balance. All the fuel got consumed, right?
Lambda, yeah,
right. It's lambda is 1.0. Yeah. And if you go a little more than that, that's lean.
Yep.
And a little under that is
higher
rich,
than 1 is lean, lower than 1 is
and
rich.
Here's the really neat part. The variance that allowed for the cat to be in its optimum window is like 0.995 to 1.005. It's not a big spread, right? So what I'm trying to impress to all of you folks is that even if it's out a little bit, maybe it won't turn the check engine light on, but it's going to cause overheating conditions in the catalytic converter, and that's going to affect its longevity. So again, it's all about keeping that catalytic converter happy and everything that goes along with that.
Another thing we should add there, the catalytic converter is an oxidizing cat, meaning from 1996 up, here in the US, 98 and up in Canada, we no longer have any air tubes like in the old days going down to the cat. The cat needs oxygen in order to break down NOx in the rhodium part, HC and CO in the platinum palladium part of the cat.
Thanks,
so oxygen plays a big
oxygen
part.
Storage, exactly.
Big part.
Yeah.
Now, how does the ECM manage to take care of all these responsibilities that it has? Well, we were talking about that earlier. Being a manufacturer, when you have engine control modules, they're a little black or silver box. And I can lay one on the bench right here, and you know what? It's not going to get up and dance. It's just going to lay there because it can't do anything by itself.
Software.
It's all software. It's all programming. That's the first thing I want you guys to write down and make a note of tonight. Programming. The ECM has to be told what to do and how to do it. So it's very, very critical. Where does that come into play? Well, sometimes the parameters that they put in there aren't necessarily correct, and they have to be changed down the road.
It's amazing how many drivability problems and other problems on vehicles and other modules are repaired with software. I had an old colleague used to tell me in the hotline, used to say, better living through better software. So in this case, it used to be better living through better medicine. Now it's better living through better software. And the software updates are, anywhere from the middle of the road frequency to some manufacturers update quite a bit. It's just easier to fix things that way. And this has been since the day when we were young techs, mem cows and cow packs, all that. Now it's done obviously through programming with a J2534 pass-through or the factory scan tool. And that is the key. If Fred doesn't have the right mental outlook on what's going on with the big picture of all the sensors and the actuators, then Fred can't do the right outcome, can't make the right decision. I just want to make a plug for a website. If you just Google this, I don't remember the website, but G and Pete, you probably know the HTML, whatever, but it is just Google GM Cal ID, GM CAL ID. Put a space between the GM, the Cal, and the ID. But the Google search, not Bing or one of the other search engines, Google tends to find that like that. And you'll get that GM website where you can put the 17-digit VIN number in there. We're going to be working on Honda tonight on camera. But if you have a General Motors product, if you've done this very long, you're calling your mobile tech or you're getting your J tool or your Tech 2 or whatever you're using to flash out on a lot of GM vehicles to fix a lot of problems. And if you're not doing that, even before you call that mobile tech who might come to your shop and do this like a third party, sublet labor, you got to know if to pull the trigger, or I should say, call the phone number for your mobile tech to come program a PCM update. If you don't know how to put in that 17-digit VIN number into GM Cal ID, the website you get when you Google that, you're kind of up the creek because there may be a fix that you'll never repair with injectors or coils or some of those wonderful Delphi Technologies sensors that you bought from one of our parts WDs. You'll never fix the car if it's a software fix. You've got to do the software.
Got to do your
programming.
homework. Yeah,
and let's talk about the biggest code in the U.S. and Canada, P0420-430.
Yeah.
Many times it's only a software update, not a new cat.
Yeah.
And same with a P0101, notorious on Nissan. You could put a new mass airflow sensor in, and guess what? You can fix it through your program.
Yeah. And that's a good time to interject this. You're going to hear me and probably others say this more than once tonight. You already heard me say you either fix it right or you fix it wrong. Part of it is going in and doing your homework, doing the research on the system that you're working on or the code that you're diagnosing. I don't care if you've done it 1,000 times. Even some of the simplest repairs today are not so simple. You've got to, as my good friend Mr. Trullia likes to say, RTFI. You've got to read the friggin' information. You've got to do your homework. And what I tell guys now is that if you've never done something on that particular year, make, model that's in front of you today, take the time to read up on it before you even crack open the hood or open up your toolbox, because you may save yourself a lot of headaches in the long run. And part of that research is TSBs, looking up the technical service bulletins that will tell you, hey, that P0420 you're dealing with, there's a flash for that. If your vehicle has this particular calibration ID in it and it's in that range, well, guess what? The only thing you're going to do to fix it is to perform that reprogramming. Now, I'm sure some of you who are watching are doing that in your shop, and I'm willing to bet that a lot more of you are not. That's okay. If you want to learn more about that, write this down. Ready? Here we go. www.N as in November, A as in Apple, S as in Sam, T as in Tom, F as in Frank. That's the National Automotive Service Task Force.org. Go to that. Very first thing I want you to do is click on the little button at the bottom left that says open a free account. Join NASTIV. Costs you nothing to do so. This organization is the stand between us and the OEMs. You have the access that you have today because of organizations like NASTIV. And this stuff right now, my friends, is under attack.
It is.
You have got to make, and a good example, anybody dealing with problems with the secure gateway module, well, guess what? Chrysler ain't the only one doing it anymore.
Right.
More are coming. You need to be aware of this. You need to stand up for your rights, and you need to not sit on the sidelines, let somebody else do the fight for you, or you're going to find out that we all lose in the process.
And becoming
right?
a NASTIV.org member, National Automotive Service Task Force, is free.
Yes.
I thought it was a membership thing. Oh, I'm going to have to pay $100 to do an expensive part of that. No,
Yeah, it costs you nothing.
it's free if you become a free member. But whether you're a member or not, NASTIV.org is the organization, like Pete said, between us and the aftermarket and the OEMs to kind of get that information to us for a reasonable price, get software downloads for these breads, the ECMs for better programming, better software, and also the software for letting your J2534 universal pass-through become on a lot of 2018 and newers, all 2018 and newers, light duty, trucks and passenger cars, and a lot of brands, GM, Honda, the Honda we're working on, so forth, as well as Toyota, several other manufacturers well before 2018. So the Right to Repair Act that was signed into law in the state of Massachusetts several years ago, and I think almost signed into law in some other states, but they kind of held it short. They have something called a Memorandum of Understanding, and that's where all manufacturers, I should say the major manufacturers, some of the exotic cars from Europe and so forth, don't necessarily sign in. I don't think Tesla signed in, but if it's a Nissan, a Volkswagen, an Audi, a Honda, a Chevy, whatever, those manufacturers says we will give for a reasonable price to the aftermarket access to programming software, access to the service manual online, electronic service information, and the access to scan at true factory levels with your J tool.
Right.
So this is important information, but if you can't remember NASTIV.org and you just want to get to the Honda website or a GM website for the service manual, for emergency responders, for hybrids, high voltage vehicles, just remember this: OEM one stop, the number one, stop.com. OEM, the number one, the word stop.com. And that's actually sponsored and made by NASTIV.org.
Yeah. So, and that, again, like Dave says, all links to all the factory service information sites. You can find out what the requirements are for these different manufacturers for programming. Get the training before you dive in. It's easy to make mistakes, and you don't want to brick a $2,000 module, in the process. So get the training before you dive right in. But I encourage you to investigate it, because that is a good way to keep the money in-house and not send it out the door.
Well, let's not forget, if they're replacing modules, then they need to get an LSID or VSP.
Good point. Good point.
They won't be able to do anything with that replacement module.
Yeah, and this again is through NASTIV.
Through NASTIV.
What we're looking here is the Vehicle Security Professional Certification. Right. And there's a process to go through, but this vets you so that the manufacturer, because all of this stuff is security related. If I have access to that information, I can just walk up to any vehicle I want, grab the VIN, make a key, and take it home. So this is one of the reasons that they do that. And it's a very easy process to follow. Right.
Since we're talking about PCMs, ECMs, the FRED, if I'll call it that, those modules are the key to starting the vehicle. Obviously, the air, fire, fuel part, and sometimes cranking the engine. And if you have a smart key, you have an immobilizer, you will probably need to be involved in what you're talking about with that secure, what'd you call it? Secure
Vehicle Security Professional.
Yes, Vehicle Security Professional.
VSP. Yep. All right, so moving along now, so that covers the ECM, the dumb little box that it is. But now that we've got the programming, it knows what it's supposed to do when it sees certain things. So what tells it what those certain things are going on? Well, that's all the sensors on the engine. That's the MAP sensor, the MAF sensor, the O2 sensor, the air fuels, everything. Everything that supplies data to the control module, that falls in the sensor heading. So now what essentially the software engineer is telling the ECM is that, hey, if you see this, do that. And if you see that, do this. And a variety of other combinations for the actual engine management. In addition, with OBD2, the software engineer is also able to tell the ECM that says, hey, we want to help you make sure that the sensors are telling you the truth. So here's a way you can check it. Do this, this, and this, and see if the sensor does that, that, and that. So we're going to talk about that as well. So it has a way to verify and keep an eye on the sensors to make sure they're telling it the truth, right? So once we got the information, plugs it in the programming, and then it's got to do something. It's got to take some kind of action. It's going to fire the plug. It's going to open the injector. It's going to open the purge solenoid. It's got to do something. Those are the actuators that are attached to your control module. So there you have it. Very simple. It's not complicated. ECM has programming. It takes in information. It applies that to the programming parameters that the software engineers have plugged in, and then it carries out the actions it was told to carry out in that programming.
Yeah, that maybe turn the AC compressor on if it's the PCM driven or controlled, and they all are. Or it may just be, more importantly for tonight's topic on engine management, injectors, coils, coil on plug, coil near plug, DIS, whatever engine to vehicle you're working on the bay, it's all going to rely on spark and fuel. But we're going to get into the air tonight as well.
Yeah, we got quite a lot of good stuff for you. So now I just mentioned that we can do certain things where the engine control module is taught how through its programming, how to keep an eye on itself, to keep an eye on everything it's in charge of, the sensors, the actuators. Well, essentially, there are 3 ways that the ECM will do that. First is one you're probably the most familiar. That's just doing an electrical circuit check. Is it open? Is it shorted to ground? These are the circuit high, circuit low codes that you see set by the
they pretty much run all the time, Pete, right? You don't have to go into mode 6 and find the OBD test results. It's pretty simple. Usually the first ignition cycle, or you might have to put some RPMs or some put it in gear or some BSS, but you're typically not going to have to do a couple of emission cycles of trips, OBD2 trips, to get one of these open circuit or shorted circuit codes.
Right, absolutely. And then the second way the ECM can perform a test is, or I refer to it as a functional test. What does that mean? Well, let's just take the purge solenoid, for example. If the ECM wants to make sure that the purge solenoid does indeed open when it's supposed to, it's going to pick a time when it's not supposed to and open it for testing purposes.
Yes.
So now we're going to take that rich, that fuel-laden vapor, we're going to put it in the engine, and what does that do to the mixture? It's going to make it rich.
It's an intrusive test.
It's an intrusive
smoking
test.
Up the works, making Fred think a little differently. It's like, hey, I know this should mess up the O2 sensor reading a little bit. I'm going to do it anyways, and if it doesn't, hey, it didn't work.
Exactly. So when the ECM doesn't see the result it expects to see, it starts taking a closer look at that component and may set a code for that component. And finally is the rationality test. This is when the ECM is comparing one sensor's output to another to see if they two are in sync with one another. A common one I can think of is TPS and math. Yeah. If you see a correlation or rationality error code, this is what it's doing to test that. Now, why do we want to make a point of this? Well, I went back to flow charts, guys and gals. That's all fine and dandy, but if you don't know what you're testing or why you're testing, it's just a waste of time. And all too often in the really real world, you get a 7-8 page flow chart, you get to step number 27 and go like, well, I know that can't be it. I'm going to skip ahead to step number 42.
Yeah.
And next thing you know, you're Alice in Wonderland. You're down a rabbit hole, and you're just not coming back.
Or you're firing the parts cannon. And don't get me wrong, we appreciate you buying the parts. We'd kind of like you to buy the one part, or maybe two, that fixes the vehicle the first time, and do the one and done, right?
Yes, absolutely.
I do it one time, and the car's done.
Absolutely. And I want to go back to something Dave mentioned earlier. That this is not necessarily an OBD2 webinar. We do have this information in the library. Encourage you to look it up. But like he was referring to, the circuit tests are done continuously. That's a group of monitors, the comprehensive component monitor. Another one that's continuous is the fuel monitor. And that doesn't mean that the fuel pump's running, but it means, is the engine taking care of that stoichiometric ratio?
Right.
And then we have the misfire monitor. Why are all these running all the time? Because these are the ones that are going to cause that catalytic converter to overheat and be damaged.
Kind of the OBD1 days. Those were checked then.
Right.
With OBD2, we're doing more things that, as you said, is in an OBD2 full class.
Yep. And we're going to kind of hit on that when we start talking about the advantages of Global OBD2, the tool.
Yeah.
And we'll explain that more when we get to that point in the presentation. All right. So, guys, who is your real customer when it comes to dealing with a check engine light or drivability complaint? Yeah, Mrs. Johnson may be pulling out the credit card to pay the bill, but you have got to make the ECM happy. What did I just tell you? It's going to do the tests. It's going to check your work. It's going to be like the teacher you had in junior high school. show you work on your math test. And you didn't do your work right, she's going to check your work. Well, the ECM is going to check your work. And if you can't meet the ECM standards, guess what it's going to do? It's going to thumb its nose up at you. It's going to turn the check engine light back on. And gee, what do we call that then?
You suck light.
And let's be honest, guys, when you have a customer that pays you good money to turn it off and it comes back with the same problem again, they're not happy. I know you're not happy. We'll show you some ways too about how you can make sure that doesn't happen to you as we go along. Hey, I know it's on the slide. It's in your handout. I don't care. Write this down anyway. Highlight it, circle it, underline it, whatever you want to do. When it comes to an engine drivability complaint, whether it's code or no code, if it's affecting the operation of the engine, it's surging, it's shuddering, it's got a miss or stumble in it, whatever it might be, there are only 4 things it can be. Only 4. It's easy. Let's talk about the 4. The first one is it's got to be an engine sealing or compression issue. If the engine can't seal the combustion chamber and it can't compress the air charge, the engine's not going to run right.
Right.
Okay. Number 2 on the hit parade, volumetric efficiency. What does that mean? Well, you saw my buddy, Mr. G, with the mask on. Can I breathe?
I don't know about that.
I think your VE is a little below 100.
Little
right
hard.
now.
He's a little VE's a little low for he and Ms. Doreen tonight. But can the engine breathe? And you know what? Probably the first few things that come to your mind when you think about a restriction in an engine's breathing is maybe a clogged cat or maybe a clogged air filter. Yeah. But it's a lot more than that. And this is what I want to impress on you guys. Any factor that prevents the right amount of air getting in and getting back out again affects breathing, cam timing, VVT operation. Is the valve opening and closing at the right time or the right amount? You know, all of these are different factors. Carbon buildup, right, is a biggie when it comes to proper volumetric efficiency. So we need to make sure we check for that and rule that out as a contributor to our drivability problem.
Things, air filters, air snorkel.
Yeah, very simple.
I had a 3-cylinder once with a turbo, and the turbo wasn't working, and it wouldn't get out of its own way. So think of the things that normally you don't think about when you've got your back to the wall. I've seen dual wall exhaust pipes, the inner wall collapsed. So there's a lot of things beyond just the usual plugged cat, plugged air filter, stuff like that.
And you bring up a really good point. And so did Mr. Julia. When you're doing your diagnosis, and we're focused on drivability tonight, but this applies to any troubleshooting situation that you're in. Never assume this can't be it. Never tell yourself, well, I'm not going to need to worry about that. There's no way that can be the problem. Because you know what? That's the problem. It isn't what you don't test. That's the problem. And I know I always get this wrong, but I'm a Star Trek fan. I like Mr. Spock, right?
I do too.
And I remember that in one of those movies, he says something to the effect that no matter how improbable it might seem, if it's the only thing that's left, no matter how impossible, then that has to be the problem. I know I screwed that quote up. I'm sorry.
Close enough. We might call it Murphy's Law.
You know, it was actually penned for the character Sherlock Holmes when he was saying, if you go through every possibility, no matter whether you think it's not possible, but you go through it anyway, when you get all done eliminating everything, it's not. Whatever's left over, no matter how crazy it might sound, has got to be what it is. So what I'm trying to get a point made here to you guys and gals is that when you're doing your troubleshooting, never assume that it can't be something. Everything is suspect until you prove it otherwise. And that's how I like to approach my troubleshooting, Dave. It's like when I deal with a problem, I'm going to go through and find everything that it can't be until I have whatever's left over.
I'm guilty of sometimes tunnel vision. It's a new vehicle with new equipment. Maybe it's a plug-in hybrid, but it's still got an engine, all right? Maybe it's some motorized VVT, whatever. Something I'm not familiar with. I get kind of tunnel vision on that system, on the unknown. And maybe follow a flow chart. You know, it's not a bad idea to follow flow charts, but never get too focused on the high tech where you forget the low tech. Because, Pete, I'd like to summarize these two up. We always used to say this in a lot of shops and training classes for millennia almost. Air, these two would be air, fire, fuel. Air, fire, fuel. So the air part is the part I think sometimes we overlook, and we get focused on, well, what's the computer doing? What's Fred doing with the fuel and the ignition? We focus on that. We focus on sensors, and we miss the simple things that Fred, the ECM, is covering up.
Right.
And they
Good
can
point.
really sometimes stack up and cover up quite a long time before drivability symptom starts, or even yet a money indicator lamp, or misery indicator lamp, I like to call
Depending
it.
on which one you call it. It's money the first time around.
So what do we use to find out if we have air? There's 19 to 21% oxygen in this room, not behind my mask, by the way, in this room. How do we do that when we're working on a vehicle?
Well, there's the oxygen sensor, obviously, whether it be a wideband or switcher, and then there's 5 gas analyzer. There's a couple
Well, let's
things.
say we got a no start. We're going to use our vacuum gauge, or better yet, nowadays, what are we going to use? The pressure
transducer to give a scope pattern that we used to look at exclusively on ignition with the old big box analyzers. And some of you techs are using, the coil unplug inductive pickups, maybe the clamp on if it's coil near plug, something like that. And you're using your scope once again, a small scope, PC based scope. Now we also can use that same scope with a pressure transducer, basically a very hardened map sensor that will screw on the end of a compression gauge hose and right into that cylinder.
Yeah, and we're going to show some highlights of that and other methods to use to check all 4 of the areas that we're talking about. So the next one on the list, that's kind of one of the easiest ones. That's ignition. We know we got to have a good, strong spark. It's got to happen all the time. It's got to happen at the right time. So that's an easy enough one to verify, right?
Right.
But number 4 on the list is my personal worst case scenario. That's fuel. You have to have the right amount of fuel. You have to have it at the right time, and it's got to be in the right manner. And we're going to really kind of hammer on this because there are so many little factors.
Oh.
And again, I want you to keep your minds wide open here, guys. When I'm talking about fuel getting into the combustion chamber, well, you know what? Stick around. I got more for you coming, all right? So let's talk about the first one. We said engine sealing, compression. That's one of the easiest things to check right off the bat. It is if you got a scope. I'll say that. If you're going to use a traditional testing method like a mechanical compression gauge or a cylinder leak down tester, that could take some time, especially on these transverse V6s. I've seen some flat rate times as much as 3 hours to do that test. Let me ask you guys a question. You have a car in, no code, but it's not running quite right. Just doesn't feel like everybody's home, right? So you suspect that maybe there's a weak cylinder. Don't know why it's weak. Could be fuel, could be ignition, could be seal and compression. So you go to your customer and say, Mr. Customer, I need to check your engine compression. And the book time on it is 3 hours. My labor rate's $150 an hour. So that's $450 for me to perform this test. But I got to tell you now, it may or may not tell me what's wrong with your car. Do I have your permission to do the test? What do you think they're going to tell you? They're going to look at you like you're out of your friggin' mind, right? So again, this is one of the reasons I like the scope. I'm going to show you a way a little bit later on that you can make that same you can make that same test in just a matter of minutes, no matter what the engine design is. It's going to be, well, we'll talk about that when we get there. So, and then as Dave and G were mentioned earlier, a more accurate and more in-depth check is when we actually can take a pressure transducer. Where a pressure transducer is just an accessory for your scope that takes pressure, whether it's hydraulic or gaseous, whatever it might be, converts it to a voltage output that your scope can display on the screen, and it allows you to see the pressure change in the cylinder over the entire 720-degree cycle. This is some groundbreaking. It's been around for a few years now, and I got to say, hats off to Mr. Bernie Thompson at Automotive Test Solutions. He's the guy that came up with this testing method, and he is, as far as I'm concerned, is the expert in the field. I encourage you to go to Automotive Test Solutions website, just Google it. You'll find him very easily, and check him out on YouTube, because if you really want to improve your diagnostic strategies and your strengths, that man can teach you a lot in a very short time, just following him along.
He is a genius.
Yeah.
Pete, just want to add one thing on that.
Please.
Some technicians I run into in my training classes on the web, out in the field, conferences, doesn't matter. They get discouraged because they'll buy this piece of equipment and they'll use it once or twice. And they'll go, Jesus, I'm not getting the pattern. We've all been there.
Yes.
I mean, you were there on a 3-phase fuel pump,
Yes.
It's like, man, how'd you get that pattern, Dave? And you got a different pattern than I got. It's not about a pattern you get. It's not about any of the details. It's about getting started. That's how you reduce the frustration and prevent that pressure transducer or that PICO or that automotive test solution, whatever scope you got, the one in building your Snap-on, like you said, whatever you've got, that scope can become a dust collector. Just like those big box analyzers when you and I were young technicians became dust catchers and maybe a sales point, for your shop's front end, but you never used them if you're as old as us. But some of those techs were using them and mastering them.
Yes.
And how did they get there? It wasn't because they were smarter. It's because they were persistent. You have to be persistent. You have to not give up when stuff gets confusing. There are slow times occasionally in your shop, admit it, where you get that phone out and you're playing Candy Crush or something like that. Maybe it's extra time to clean the floor, whatever you're doing, talking to your better half on the phone. Take a few minutes of that time and just hook a scope up to something that is okay, working right. And that's how a lot of us eggheads figure out what something doesn't look right, because we scoped a few things that did look right, and also not busted our knuckles, but kind of busted our own chops with frustration of hooking things up and going, why am I not getting a pattern I'm supposed to get? It's just going to be one of those things. You got to pick yourself up and keep at it, persisting.
Yes.
You'll good at it. You'll get good at it, just like most of you should have by now gotten good at using your multimeter.
Right. Absolutely. That's a great point, Dave. And again, like he was saying, you don't wait till something's broken to try out a new testing procedure or new tool. You try it on known good vehicles when you got the time. And I'm going to tell you, you are here tonight. So we know we're preaching to the choir. You're here because you want to be a little bit better than what you were before you got here, and maybe be entertained a little bit at the same time. That's okay. But you're the exception to the rule. And because of that, we know that when we give you this advice, you're the audience that's going to take that to heart and put that to work. And again, I'm going to stress again, you've seen our email addresses. None of the three of us are feeding you a line. If you break that scope out and you have a problem, you say, I don't know what's going on here, you can send a note to any of us and tell us what's going on, and we'll do the best we can to help you or point you in the right direction. I'm not perfect. I don't know everything. Certainly don't ever try to claim to be, but I've been in the side of the business now for, like I said, over a dozen years. I've met some really, really smart people like this guy here, the guy behind the camera, Mr. Thompson. I can get you an answer to whatever is ailing you, but you got to take that first step, right? That's a great point. Appreciate that. All right. Here's an example of a relative compression pattern that we're going to actually demonstrate this on the car. If you could put that screen up.
It's up.
It's up? Okay. I'm sorry, it's delayed. If you can, all we're doing here is looking at a current pattern. My scope can show anything we want it to show if we have the right accessory. So we're looking at a starter current pattern, and we've disabled the engine so it won't start. And you'll notice that you see all these little peaks across the screen. Every single one of those is caused by a piston coming up. Let's see if I can get that little button there. There we go.
Oh, beautiful.
Every one of those peaks is caused by an individual cylinder coming up on top of the center compression. Now, why is that the case? Because a starter motor, when it's made to work harder, it takes more current. When it's not working so hard, it takes less current. So if any of these cylinders were lower than the rest, that would indicate a cylinder that wasn't pushing as much resistance to that starter motor as a good healthy one was. And we're going to show you, and that's how we pinpoint where there's a weak one, okay? Make a note here. Make a note. Write this down. This is a 95%, what I call a 95% test. If I take this test and I see a pattern like the one you just saw, I am 95% sure I don't have a sealing or compression issue. Why? Why do I say 95%? Let me explain it to you. Sometimes, and today even more than ever, we have intermittent sealing issues that can be caused by carbon or other mechanical conditions. Maybe there's a valve that's not quite true on its seat. You know, what do valves do? They rotate. Yeah. And as the engine rotates, most of the time it might be right in the right place, but every now and then it hits that spot where, like the bad starter motor, where it's not going anywhere.
That spot, that little sweet spot where that valve, as it rotates, is normally supposed to just turn like this and rotate around, so it's not sealing the same exact spot over and over and over again. That valve may not rotate and hit that spot while you're doing a cranking compression.
Exactly. So you may not catch it with this particular technique. So that's one of the reasons I like to say that. The other thing is it's relative to all the other cylinders. So if you have a condition that is causing all of the cylinders to be lower in compression, I don't know, timing's off, timing chain is off, something like that, you're going to see the same peak and valleys that you just saw on the diagram, but they're not going to be as tall. Okay. So it might look originally okay to you and not be.
And it'll run like crap, maybe even have a no start, misfire codes, but you won't have any kind of a cutout.
Single dropout
of that. And what this is the energy of the starter motor in amperage making more work of that increased energy as that piston moves up on top dead center compression. They don't all do it at the same time, as you professional techs know that, right?
Right.
So it takes an order, the firing order. So if we see one of these pulses in extra work amperage from the starter with that simple amp clamp, and Pete, I think this is the simplest test any technician can do. Get a high current, like you would check your starter with, 0 to 200 amp, whatever you've got, amp clamp that can connect to a scope, usually through a B and C type adapter, but you may have to get some kind of a adapter to go from banana plug to B and C or vice versa. Whatever your scope has, this is the easiest thing to do. The really challenge is getting it to crank without starting on some of these smart keys.
Some of the new smart keys
to do live on this Honda over there.
Yeah, absolutely. And to kind of mess with Dave here, says you don't have an amp clamp, you can still do this test. I'm going to show you how to do that. Okay?
That's right.
So we'll do that too. And this is a great example of that. You got a dive wrote it, perfect lead in, right?
Yeah.
I want you to take a look at this diagram, guys. The blue trace here on the bottom is the starter current, just like you just saw. It's opened up a bit. The green and the gold are voltage measured at the battery. Now, what happens when the starter current goes up? The voltage in the battery gets pulled down, doesn't it?
Right.
So you can actually check this using just battery voltage alone. And I have two here for one reason. One is measured directly at the battery. The other one is measured using a breakout box or a bob at the DLC. Now, of course, a voltage drop is in one direction, while we usually show current going in the other. So all I did here to give you that almost mirror image was to invert or turn upside down the two voltage patterns.
Yeah, and since the old Sun VAT 40s, right? If you're old guys like us that can remember those.
Keep saying old guys, dude. I'm not that old.
We're only as young as we feel, right? I feel pretty old right now. Not as old as Mr. Chillia here. He's a little under the weather today. But if you remember Sun VAT 40s, for example, I mean, you had two analog meters, amps and volts. That was the V and the A of the tester, VAT. But if you've got a newer one, and you're using a handheld tool to check your starter and your battery and your alternator, those are digital typically, and you don't catch as many things digital. In fact, with the old needle, you couldn't ever see this. So any scope, like you said, the back of your scanner, whatever you've got, an oscilloscope, you don't have to have multi-trace. It could be one channel scope. You can see these things, these variations in voltage and variations in current, like I talked about, if you have a real-time device like the scope.
Right. And then the other thing we hear all the time is, well, Pete, by the time I get it out of the box and they hook everything up, I just moved on, I do something else. When you go to the shop, do you turn the lights on? Coffee pot? Start the air compressor? Of course you do. Just make that part of your everyday process. Have your scope up and running. A lot of you guys have been, and I love seeing the pictures of your diagnostic carts where you've got your monitor set up, your scope equipment all in that one cart, and it's ready to go at a moment's notice. And that's because you're the guys who are using it. If you're getting started, just do something simple as a battery starting charging system test with your scope. When every car that comes into your bay, you're getting experience, number one, and you're providing a very valuable service to your customer, number two. Here we are in New York in November. I know that some of Mr. Trullia's family is up there in Buffalo. I think they've got like 4 feet of snow already. Now, a few days ago, that car might have started just fine with the battery that was in it, and today, not so much. you can tell that with your scope capture. You can do that test for your customer and avoid having them run in a situation where they are that no start calling a tow truck when they didn't have to if you had done that test for them. So it's very easy to do. Again, go back to that library of webinars that you have access to, and you'll find the one that says how to do the battery starting or top 10 tests for scopes, or there's a bunch of them in there. And if you don't find it there, you can go to the TST YouTube channel or the Motor Age Magazine YouTube channel. And of course, you can visit Delphi.
I want to make a point right now. I want to ask G and Doreen, who are moderating and watching the chat box. Does anybody ask I think would be an obvious question if you've done this quite a bit or never done it at all, the volts or the amps relative compression test. Is anybody asking what this big sharp spike is when it begins? Always there at the left. And as you go down left to right, like reading a book, it kind of straightens out. And this is what we're really focused on, right, Pete?
Mm-hmm.
What is this right here? I'm going to ask the question if nobody else has. If you haven't asked a question on chat, I'll ask it for you, okay?
All right.
So what is the big spike?
All right. So we'll go ahead and leave that out there. There's a slight delay. So we're going to kind of give it just a minute or two as you guys put some answers in. So what Dave is asking you guys is, we know what's causing the loops here, but what's causing that sharp upward spike at the beginning? Let's back it up and you can see there.
Same thing.
You can see how much higher this little spike here is. And just what's causing that? What do you think that is? And we'll just give it a minute to see what kind of answers we get.
We should get a lot of answers, but if we get some, I don't know.
Yeah, that's fine. If you don't know, that's fine. That's why we're here, right? I mean, so tell us what you think. I want to know what you think, and don't be ashamed if it's like to borrow this from Mr. Julia, is like I can't see you. Nobody else can see you. So who cares if somebody thinks that, you were less than smart.
John says inrush current. The big spike initial draw where the starter is free spinning at first. DN. Another guy, Daniel, inrush.
A lot of good results. I can see the clicker just clicking.
Normal initial production kit.
Okay. So and yeah. And we appreciate it so much when you guys interact with us and like this. Yeah. And you guys are doing a really, really great job. So I'm guessing you guys are the scope guys in the crowd tonight. You understand, again, as Mr. Julia pointed out earlier, you're looking at a device that can literally capture data in microsecond times. So when we first turn that key on, we first energize that starter motor. Well, the starter motor is going like, what? I was sleeping. I don't want to get up, moving. Jeez. So I got to get that thing moving. And then I'm asking it to do work on top of that. Not only does he get in and out of bed, but I'm asking him to like carry luggage or move furniture around or something. You know what I mean? He's got to go against all of that inertia in the engine, get all of that mechanical parts moving. And that's a lot of work. So right at the very beginning, it takes a lot of juice. That's where you see that high peak current. And that's not the starter current draw that you would do an old traditional test on. It's only that microsecond period of time where the maximum demand is being placed. It's not unusual to see 500 or 600 amps when it gets to that peak, and it's fine. There's no problem with that. As most of you guys explained, it's called inrush current. The same thing applies on the voltage side, and it's just the same inrush voltage. Same thing. We're going to see a huge drop in voltage to correspond with that huge current demand.
Now, we had a question here. How do most guys disable to do this reading, disable the system?
We're going to show you on the Honda because it wasn't easy.
Yeah, the number one thing is we don't want to wash the cylinders down. We have to disable the engine so we can allow it to crank for a little bit to get that pattern captured, and we don't want to wash the cylinders down in the process.
Although I was willing to do that with this rental car, and you guys stopped me. Okay? I should admit that on camera.
So, right to answer your question, and we'll show you here.
My rental car was Pete's, okay?
So, to answer the question now, and we'll demonstrate it again when we get to the car part, when you're doing your relative compression test, first of all, you have to, just like you're doing a regular traditional compression test, you got to disable the engine from starting so that you can crank it over. On a lot of vehicles, if you just push your foot to the floor, you can put it in clear flood mode and the engine will turn over without starting. So you can try that. If it starts, okay, you can't do it that way. If it just cranks, there you go, you're ready to go.
Let me ask a rhetorical question, because I already know the answer on this, Pete.
Okay.
I believe earlier when we hooked the scanner up on this Honda, you put your foot to the floor and the pulse width did not decay down to nearly zero. So that's how we were determined on this vehicle. I believe, correct me if I'm wrong, that it didn't have clear flood mode.
That could be I didn't use that, but that's a great observation. I've never even thought about
I've done
that.
it on
but
some
yeah,
vehicles,
that's a good
I put
thing.
my foot to the floor and thinking,
yeah,
clear flood mode. That was around when I learned TBI. Okay,
right.
That was a long time ago. Now I'm thinking, surely that's gone away with some of these modern, PZAB vehicles, yada yada. No, some of them still have it. And you put your foot to the floor gradually, and you see the pulse width go up on your scanner. We're talking key on, engine stopped. And there's a kind of a trick. If it's got a smart key, you may have to read the manual or get on IATN, a diagnostic network or whatever, and find out what that knack is. On some vehicles, it's simply leave your foot off the brake, hit the power button. On others, you may have to hit the power button twice, something like that, to figure out what that is to get the equivalent of key on, engine stop, ignition on, engine stop, and then push your foot to the floor on the accelerator pedal, watch that TPS and PID, data parameter ID, and watch that pulse width of the injector go up and up and up, and then decay down to nothing or nearly nothing. That's clear flood. So you could use a pogo stick. That's why I call them those little sticks you can put between the seat and the gas pedal, and hold it down that way, or have a coworker, hey, hold that down and crank it, or hit the power button, whatever, and just see if you can do the cranking compression. You'd have to do that if you pulled the plugs out anyways, to do old-fashioned, time-consuming,
right,
would you say 3-hour
yes,
test.
yeah.
Or you could just do that.
Right? Yeah, and then the other options, if you can't use clear flood, then you have to disable fuel pump relay, fuel pump fuse, to unplugging the injectors, whatever you have to do to make sure that we're not washing down the cylinder. So
if it's a hybrid, you want to see if there's the availability with the scan tool, or with some, I'll call it as my colleague in the training business, Dave Scaler, used to call it the hokey pokey. Well, he used that metaphor with TPMS resets. I'll use the hokey pokey, left hand in and the right foot out, all that stuff, and get the right button presses. And you probably remember, because you've got a Prius out here you use for training, to get into cranking mode. There's inspection mode that keeps the engine running, so it doesn't do auto stop. And then there's a mode where you can go into, and usually the scanner is the easiest way to get in there and make that hybrid do a slower cranking test. So obviously it's going to want to crank it fast with the motor generator, and that's going to give you a little different pattern here, a little different compression reading, almost like a running compression test with the old-fashioned gauge. You don't have to do that. On some of those hybrids, I'm not sure if the plug-in hybrids you can do this or not. You might know you had a Volt, but an engine's an engine, folks. So it applies as we move forward in electrification days, which we're big in at my company, and you're going to be seeing before you know it, you're still going to be fixing those hybrids and plug-in hybrids, doing compression test and relative compression.
And I guess we should get some of this up, because a lot of the points you just made, different hybrid models, different manufacturers models. How can we know what to do? RTFI, read the friggin' information. Look at So that's a really good point. Just do your homework. So thank you for that. All right, keeping moving.
Just one note I want to add there.
Sure.
Clear flood, which I usually find about 85% of the vehicles, always make sure it's OBD2 compliant vehicle. Not that it has the 16 cavity connector, but once you get over 8,501 pounds, clear flood won't be on that vehicle.
No kidding.
Very good.
I didn't know that. Good information. Good
SAE
information.
standard. So anything over 8,501, it does not apply.
Yeah. Now I know that recently heavy duty had OBD2 compliance, but that may not be part of that package.
It's not part of that.
Right. Okay. All right. So moving along, we did relative compression, but and there's some other tests. In fact, if a lot of manufacturers, it was weird, because when I first started using a scope, you couldn't really find any factory references. The very first one I ever saw was in the old what do they call it? The Ford synchronizers that had a big problem. They basically took position of the distributor and had the cam sensor on the shaft, and they would get out of time, right? And that was the very first time I ever saw a factory put out a description of how to compare the crank and cam sensor signals to see if that synchronizer was in sync. That was pretty cool. Now, though, it's gotten more so that the manufacturers are starting to understand and realize the value of the scope in their own training materials and their own technical papers. And the one that comes to mind now is that you'll see adaptation of the relative compression test in their factory scan tools. Ford comes to mind, Toyota comes to mind, a number of manufacturers have it there. And if you've got an up-to-date aftermarket tool, quality tool, you'll often have the same thing in the enhanced mode for those manufacturers. So take a look at that. If it's already there, you can do it from the driver's seat. Do it that way.
Cylinder contribution?
No, I mean relative compression.
Relative. Oh, that's right.
Yeah.
Yeah. Don't forget, ECM from ATS as a generic tool.
Yes.
You could do relative compression.
And
Just
they're
don't
using
know what cylinder it's on.
They're using the voltage technique.
They're doing
Yes.
Automatic. And,
Right through the DLC.
And Solomon said, nothing new under the sun. Where was that first? That was in the big box analyzers.
That's right.
Some of you may remember, and if you're like me, it's like, well, I was young enough. I just wanted to make money and get the car out the door correctly. I didn't really care that much about the why. I wasn't a teacher. Well, you don't have to be a teacher now, but the why is more important than ever. And you brought that up when you very first started this broadcast. Yeah. The why, that engine cranked for about 10 or 15 seconds and then started. The Sun machines of way back, the Allen Smart Engine Analyzers, they were doing the same exact thing that we were doing a couple slides ago. They were keeping the ignition. Those were carbureted days. We didn't worry about cylinder washdown. You wasn't pumping the gas pedal. So it turned the ignition off because we were hooked into the primary, and we looked at not a scope, but we looked at numbers of relative compression based on starter current draw. And that's not a new thing. So
right. We're
just taking an old thing, bringing it forward and making it easier for you to save time and make money and reduce your frustration level.
Absolutely. Now, again, we're still focusing on sealing and compression, the engine mechanical condition. Here's another great test, and I think we already commented, this is a Bernie Thompson thing. I mean, all the applause and acknowledgement, credit, that's what I'm looking for, accolades, go to him for this. And here you can see an example of what that test looks like. The blue trace is that in-cylinder pressure being monitored from one peak of compression to the next peak of compression and everything in between. So we were able to see when the exhaust valve opens, when the intake valve opens, what's the exhaust back pressure, is it happening at the right time, is it opening as far as it should. Everything you want to know about what's going on inside that engine is in that pattern, if you know how to read it.
Now, this is with the engine running correctly.
Yes.
It's in one cylinder. You remove the spark plug. You put the adapter, the pressure transducer, on the end of a compression hose, a compression gauge hose. However, I've made this mistake. So we're going to learn a little bit from this guy. I got to take the Schrader out. Now, there's a Schrader at the top. That's when you hit the button. That's to release the old-fashioned pressure, compression gauge pressure, then go to the next cylinder. But the one in the bottom of the hose was there for a reason. With the old gauge, you could get some fuel washed up that hose and gum up the works of your gauge. I just did this test last week. I'm not making it up. Yeah, instructors do get out there in the field and do work occasionally. So I'm on this 2004 Silverado, and everything's looking great with the compression gauge. But then when we use the hose, the same hose in the same holes, spark plugs removed one at a time, the pressure transducer was giving me this crazy pattern. I'm going, I've made this mistake before. What did I forget to do? Take the Schrader valve out. Usually leave it in with the gauge, with the cylinder in-cylinder pressure transducer.
Right.
You take that Schrader out of the bottom of that hose, put it in the toolbox. Don't lose it. You'll need it when you put the gauge back on next time you want to do an old-fashioned test. Hook that transducer up. That transducer hooks to one of the channels of your scope, and we see this pattern. And that's top dead center compression, correct?
Yes.
Okay.
Right. And again, this is not an in-cylinder pressure class. This is a whole webinar all by itself. But I want to make you aware of this as another testing method that's available to you. In my mind, the more bullets you got in your gun belt, the better you're ready to go and attack the problem in your bay. All right. Next one on the list, we said we covered sealing and compression. Now we're going to talk about that second one on the list, and that's volumetric efficiency. Can the engine breathe? Again, not just a matter of maybe a clogged air filter, clogged exhaust, anything that keeps the right amount of air from getting in and getting back out again affects the engine's ability to breathe. And if I can't get the right amount of air in, I can't make the power the engine's capable of producing. If I can't get it out again, well, that's taking up space that the next air charge can't take advantage of. So the engine has to be able to breathe. Now, there's a number of factors, like I said, that affect volumetric efficiency. For example, worn cam lobes, worn or broken intake rocker arms, intake cam timing out of spec, excessive carbon buildup, or a low compression issue in that cylinder can all affect the engine's ability to breathe on the intake side. Exhaust side, well, you can have a restriction in the exhaust. You can have worn cam lobes, worn or broken exhaust rocker arms, exhaust cam timing is out of specification. Anything that's going to help keep it from getting out again is a problem. As you pointed out, here's what I never even thought of, having that dual-walled exhaust collapse and restricting the exhaust flow. You could have damage.
The whistle noise.
Yeah, you could have the damage to the pipe itself. Even if the tailpipe's gotten flattened shut because you hit that really steep angle at the Wendy's, getting your hamburger. And then the other one that's going to affect it in terms of doing your test, and we're going to talk about that more as we discuss the test itself, and that's if any of the sensors that the computer's using to determine how well the engine is breathing, or that you're going to use to make that calculation, if they're not giving you the right information, that's going to throw your test results off.
Bad information in,
bad out, right? Bad actions out. So here's some notes on how to perform the volumetric efficiency test. Number one, the engine has to be a mass airflow. Use a sensor in order to perform the test this way. Will not work on a MAP-equipped engine. However, again, pointing out to the eScan, the Birdie tool, you can perform a volumetric efficiency test regardless of whether it's a MAP or MAF sensor using that tool. And let me just throw this out here. You've heard me mention Bernie's name several times already this evening, and he probably can't hide the fact that I have a lot of respect for this man and everything he's done for the industry. If you ever get a chance to see him in person or listen to one of his classes, I encourage you to take advantage of that. And I'm going to say right now, not trying to sell you anything. None of us here are making commission off of anything that we share with you. However, we've all been there, done that. We've got the battle scars. We know what it takes to make a living in this business. If I know of something that's going to make your life easier, make you money, as Dave pointed out, we would be remiss if we didn't share it with you. And if you're looking for a good drivability tool, and we're going to show you why we're big fans of Global OBD2 to start with, you take that tool, Global OBD tool, and all the other assistance that it provides for you in terms of like the volumetric efficiency test and such you can perform, it just makes you so much more effective, more efficient, and again, accurate. But if you're going to do it on your own, which you certainly can do on a MAP-equipped vehicle, we're going to go over the steps real quick. This is, again, is in the handout. And you also have the calculator that we're going to reference for you as well. You can download that. It's an Excel spreadsheet. All you got to do is plug in the values, and it'll do the calculations for you. You're more than welcome to use that.
Be a spreadsheet geek.
No.
Just open it up, put the numbers in.
Yeah, just put the numbers in.
Tool,
yeah.
And then hit enter, right?
Pretty much. Yep. Okay. So here we go. First, again, it has to be equipped with a mass airflow sensor. Connect your scan tool, select the following PIDs, and graph the data. Very important for you to graph the data. You want the mass airflow in grams per second. You want to track engine RPM. You want to track intake air temperature, barometric pressure, and if you don't have that PID on your scan tool, you can look at your local weather forecast and you get an idea of the barometric pressure in your area. It doesn't have to be spot on, but that'll be good enough for the test. Some online apps that you can use that's not the spreadsheet, but if you Google calculators, you'll find a few online. They'll use elevation as a number to put in instead of the baro, and that's really what's affected, right? And then I want you to put short and long-term fuel trim on the list as well. So that's the stuff that you're going to have set up for your scan tool to record as you perform the test. Now, bring the engine up to normal operating temperature, and very, very important, number two, very, very important, select a test area near your shop where it is safe and legal to perform this test, okay? And that's just kind of a side note, guys and gals. I'm a firm believer that you do everything you can to keep your diagnostic process uniform. The steps that you follow, the road tests that you take, always do the same one so that doesn't contribute to the cause or the effect.
In the scientific world, I think we call it constants. And then you have set variables.
Right.
Like this case would be the PID, the parameter IDs on the scanner. Those are the variables. on a known good car or a suspect vehicle, and the constants would be the road test.
Right. And so if I know I'm going to take the same path every single time, that eliminates that as a potential problem causer, right? So we're going to find that area. You're going to set that up near your shop, start off a rolling start in first gear, and then punch it. I mean, put the throttle to the floor and keep it there until it makes the shift to second. As soon as it makes the second gear shift, you can let off the gas, go to the side of the road where you can do everything safely, stop the recording your scan tool, and note where that peak happened. Where did that shift occur? The max RPM. That's the point on the graph line that you want to collect all these data PIDs that I just mentioned to you. That's where you want to see what your max engine RPM was, intake air temperature, the MAF airflow, all of that right there at that point, okay? Then you're going to analyze the results. You're going to plug it into that calculator that I mentioned to you. And we'll show those examples for you here in a second. Now, general guidelines, when you get your number, is that if you're above 90% or more on your volumetric efficiency, probably okay. Engines can breathe all right. I'm not going to be too concerned about that. And that means all the factors that I just told you could affect breathing. The worn cam lobes, the VVT not working, the clogged exhaust, the dirty air filter. None of that's a problem. So I get to wipe all of those off the table and move on with my diagnostics. Remember I said at the beginning, I'm going to eliminate everything that I know it isn't.
Yeah.
And then when I get down to whatever's left over, that's got to be it, right? So just now I got to remove a whole bunch of stuff it isn't, right? So that's where we're at so far. Now, if you get 76 to 89%, you got to kind of take that with a grain of salt. That's kind of in that gray area. So you have to kind of consider what type of vehicle it is. Is it a performance-oriented engine? Is it kind of an entry-level eco 3-cylinder turbo? One of those little, something along those. Consider that and the other symptoms that you're dealing with before you draw a conclusion. However, if you get much below that, you start dropping into the under 75% range. Well, now you can indicate a breathing problem. If you get below a 55% VE, then that engine probably isn't even running, right? It's not moving any air.
For cranking compression
right?
test.
Now, Dave, isn't there a data PID that kind of gives us some information similar to what we're looking for here?
I think it's called absolute load or load.
Yeah.
Load.
Yeah, and there's two of them, right? There's calculated load and absolute load. And there's two different ways for those to be determined by the ECM. We're going to show some example of how they're affected. But that calculated load can give you kind of a really quick down and dirty, when you do the test. If you graph that along with the PIDs that we just mentioned, that should give you a kind of a down and dirty, quick idea of which direction you're going in, okay? However, be aware of the liar. If you're relying on the mass airflow sensor and it's not telling the truth, that's going to skew this test. But you know what? Hey, I can use this to test the MAF sensor.
You can check a mass airflow sensor for being truthful.
Yeah. If we get a bad VE result, that's why I said look at your fuel trims. Let's think about this for a minute, guys and gals. And that's why I want you to do this more and more every day. I can't stress this enough. You can go on YouTube and Google right now, and you will find millions of videos on how to fix this, how to fix the pump on your 98 GMC pickup, and how to change the plugs on your 2007 Toyota. And you just have all of these how to. You know what? I can give a man a fish. I'll feed him for the day. But if I teach him how to fish, I'll feed him for a lifetime. We want you to understand the how and the why. Yeah. That's critical to your success as a diagnostic technician, understanding the how and the why. Now let's apply that to what I just mentioned. If the VE is low, and I'm looking at fuel trims, if the fuel trims are correcting for a lean condition at the same time, well, think about it. If the air going into the engine is as low as my test indicates, the MAF sensor is reading that correctly. It's giving the right information to the computer. The computer is going to give it the right amount of fuel, and there won't be any problem with fuel trim, will there? So if I don't see any changes in fuel trim, then I probably have a breathing issue.
What you're seeing is what it's breathing.
Right.
The breathing is correct. The mass airflow is not contaminated. It is not skewed. Obviously, if it was shorted or open, we get a code.
Right.
But
don't even have to have that.
The road, I'm lying. I'm not really dead. I'm not really shorted and just inaccurate and contaminants.
Right.
Oils and stuff from air filters and you name it, environmental stuff can get on mass airflows. And here's our official stance. And I know you probably covered this in a Jobs Done Right recently for us, but if the mass airflow is contaminated and you clean it, a lot of techs are doing that. And there's products out there to market. I'm not here to cut them down, but our engineers say that is not an approved method because it takes so much heat and so much physical scraping to truly get it clean. You end up damaging the sensor. But it's a viable test to see if you had an improvement. So if you do another VE test after cleaning the mass airflow and you see the trim come into normal and you see a more realistic VE results, vehicle volumetric efficiency results, then you probably have made improvements. Now it's time to go replace that mass airflow because you don't know if it's going to last a week, a year, or a month, and we don't really want the comebacks.
Right.
We don't want the warranty. You don't want the warranty and the comebacks, and your customer wants the job done right first time.
Absolutely. And again, you've heard us mention, and I'll say it again, if you're in that market, you're looking for these engine management devices, by all means, support our sponsors, Delphi. Like I said, after all, these are the guys that make the parts for the OEs. It's the parts your car came equipped with to begin with. So they meet those standards, form, fit, function. Now, back at what we were saying, if the MAF sensor is not reporting accurately, then it may be not telling the ECM all the air that's getting in. It's shortchanging the ECM. So the ECM doesn't know this, right? So it sends the fuel amount for the amount of air it's being told is getting in. But our buddy the ECM has this buddy down line called the oxygen sensor. And the oxygen sensor is going to go, hey, I don't know what you're doing up there, guy, but you really missed on that one. That's way too lean. And then it's going to start making those corrections. That's why if you do a VE test and check the fuel trims, low VE, correction in fuel trims, somebody's lying, suspect the MAF sensor. You can try to clean it like Dave mentioned, see if you have an improvement, but odds are if it fails O2's test, the MAF sensor is no good. If the fuel trim's okay, then you truly have a breathing issue. Now, something else you pointed out that can affect that, I want to make sure guys understand, it isn't just a contaminated hot wire in this MAF sensor. If you've got something affecting the airflow through the MAF sensor, that will also skew the results. If you have any kind of turbulence coming back through, say you have a leaking valve or something going on in the intake, or maybe you have, I don't know, one of those cheap cold air intakes that the guy thinks is going to make his car run so much faster, these can cause those kind of issues. I don't know if you remember this one. There used to be a product that was, and it's still available to my surprise.
Cyclone.
The Cyclone. We can make more fuel economy. We're going to stick this little turbo-looking thing in the air duct, and it's supposed to create this vortex tornado effect that drive more air. Oh no!
Our minds are melting.
Oh my God! And that and I've seen those problems with the MAF sensor readings. And you open it up, and you see that silly little piece of junk in there. Then that's your problem. So again, you have to consider all possibilities when you're looking for the result. You know, maybe you clean the MAF and you don't see that, but you still see low VE and fuel trim corrections. Well, keep in mind there are other things that can affect that MAF reading. All right, like this. So many vehicles today now are turbocharged. So now we have an artificial device pumping more air into that engine. Well, what's the VE a measure of? The engine's ability to take in it's a comparison, right, Dave? Yeah. It's the theoretical comparison between what it should be and what it is, right? So the higher, and you will see in some cases on newer engines, you may see 100, 120% on a normally aspirated high efficiency engine. Guys, again, I gotta say this again, the vehicles that you're working on, highly technical, highly complex, marvels of automotive engineering, these are hot rods. They're squeezing every little ounce of power they can out of every little cc of displacement. I mean, you think about it. Back in our day with the big old muscle cars, you know, my 440 would never stand a chance against that little Honda. You know what I mean? Not today. That's just how technical they are. And one of the ways that they're getting that power out is they're using turbochargers and superchargers. That adds the additional air. So let's talk about that for a minute. Number one, what is boost? Boost is the amount of intake manifold pressure that's above normal, above atmospheric. So at wide open throttle, that can be pretty close to another atmosphere, another 14, 15 PSI. In fact, I know on my A 6.0. I can hit about 25, 27 PSI of boost, when it's under full load. If you can look it up, look at your scan tool and look for a PID called desired boost. Desired PIDs are really, really cool. Desired PIDs, back in the day, Dave, when we started looking at OBD1 and certainly OBD2, we see all these data PIDs listed on the scan tool. And unless you knew what they were supposed to be, many of them you weren't sure what was good and what was bad. Now, what I say at the very beginning, you have parameters established by the software engineer. And this is an example of him telling the ECM, if you see this, do this. Well, this is the do this. The desired PID is the do this for that data PID. And whether it's RPM or VBT operation, whatever it might be. So that's a benefit to you because you can compare desired versus the actual to know whether there's a problem or not. They should stay pretty close to one another under various modes of operation. So now use boost pressure, intake manifold pressure in place of the barometric pressure in your calculator. So now we can take into account that artificial effect that we're getting from the turbo. Performing a calculation twice, one using the true barometric pressure, one using the boost pressure. The first will be true volumetric efficiency, but kind of useless for comparison. You will see some numbers going 300% or more when you're looking at a turbo or supercharged engine in some cases. So the second, though, is adjusted, and that's more useful. Let's just take a look. Here's an example. This is on a turbocharged. This was a Dodge, I believe. And here's the test data that we used. MAF, 89 grams per second. RPM, 3,200 RPM. Baro, 29.8. Intake air temperature at the time of the test, 66 degrees Fahrenheit. And intake manifold pressure was 24.8. That's actually 10 PSI over atmospheric. So that's 10 PSI of boost. If I was looking in the scan tool, I would see that 10 PSI number listed there.
So that's how we get this volumetric efficiency to make that little engine at 1.6 liter put out what it does. So something an engine that used to be had to be 3 liters put out the same amount of power.
Absolutely. Absolutely. So you can see that the test vehicle load PIDs under this test, the absolute load PID read 163, and the calculated load PID was 97. So again, I want you to point out the difference between those two. They are calculated differently, but you can see that 163, pretty close match to the 173 that was actually calculated. All right. So that's without boost correction. Now let's take a look at the same vehicle with boost correction. And what I said, all we're going to do is we're going to substitute the Baro reading for the boost reading, the total intake manifold pressure. Now, we did have to do some conversion here, okay, in order to get the right number. And you may find that's necessary when you use this calculator yourselves. But now, once I put that in, now take a look at the calculated efficiency, 102%.
Interesting. So
now, see how that goes?
This before. I've learned something that if I've learned it, I'm not saying I'm a genius, but I've been around and doing this a while. If I learned something tonight, I know a bunch of you guys, light bulbs are coming on in your head right now because mine is. I've never used this particular function of a VE calculator.
Yeah, and look at the calculated PID that we had.
All the turbo cars, I'm driving one. I'm driving a 3-cylinder 1.5 Ford EcoBoost with twin injectors. I hate to admit it, but my wife liked it. Okay, so I bought it, and I just didn't know there was that out there. So that's good to know. So that gives me the 100% factoring because 173. How can I work with that?
Yeah, because it's no comparison value to it, right? So now we have something that I can compare to the chart we looked at earlier on whether it's breathing
below
or not.
100, significantly below 100, or significantly above 100 with the boost factor correction put into this chart.
Right.
Then I'd be looking at the fuel trim. Hey, is it spot on? Again, as you said earlier, it's breathing normally. But if it's way off, it's the mass airflow's lying.
Yeah, or in case it could be, yes, the mass airflow sensor will give me a problem. Absolutely. And I got to make sure, because one of the things that I always believe in, I give credit where credit's due. A lot of thanks to Scott Schotten from the Drivability guys. He's the first one I've seen actually put this information together. He actually shared it in a Motor Age magazine article for me a few years ago. So I encourage you, if you want to know more again about this particular topic, you can go to motorage.com and you can put that in the search function. Just put Scott Schotten, Shotton, and you can see all the articles that he did for us. And this is among those articles. And he actually teaches a class on that topic as well.
Cool.
I know we got the in-cylinder pressure test here again, but you know what? I can see breathing issues in here as well, as we talked about. If I do have a problem with a worn cam lobe or a valve that's opening early or late, all of those are going to affect how air flows through the engine, and I can see that using this test once you understand the concepts of the pattern. So we'll go talk about that. All right, on item number 3. Item number 3 is ignition. That's the easy one, right? Ignition, you got a strong spark. It's happening all the time, and it's happening at the right time. Now, strong spark is easy to check, isn't it?
Sure.
If you use a spark checker, right? And you guys may go, what? You can't just, in the old days, we used to take a spark plug and we'd cut off the ground electrode, and then we would use that as our spark checker. But that was okay in the day of points ignitions where the coils were producing a whole heck of a lot. Today, guys and gals, if you want to check that coil, the ability of that coil to produce that spark energy, you need a spark tester. It's a simple little device. You ground one end, you plug the coil into the other, and you can spread that gap out as big as you want.
Thread this little bolt, make it a wider or narrower gap.
Right. And then if you get a good, healthy blue spark across that, then you got enough energy to do it inside the combustion chamber under the pressure and fuel conditions that are inside that chamber. So that's easy. What I really want to call to your attention is the timing part. It has to happen at the right time. Okay. How do you check that today? Some of you guys and gals who are watching may not even have a clue about what a timing light is or timing marks that used to be available to us on the harmonic balancer. We'd have an index there, and we could use this essentially strobe light to fire off the number one coil, number one plug lead, and then we could see where that timing was occurring based on those index marks. You don't have that today. You can't adjust it, but it can still go out of whack, can't it? Everything can go out of whack. So how do you know? How can you check real quick? Again, we're going to demo this for you, but I want to call to your attention this pattern here. Again, this is just another relative compression pattern. Let's first take a look. The red trace, again, is current, but ooh, look at that. That's lower than the rest, isn't it? Oh, 1, 2, 3, 4, 5. Ooh, there's another low one. What? 1, 2, 3, 4, 5. Ooh, every 6-1 is low. Well, that's kind of interesting. It's a 6-cylinder engine. So now I know that number one, I've got a weak hole. Which one is it? Hey, I'm going to do a reference. I'm going to take another scope lead, and I'm going to tie it to the ignition event. That's what you see here in the blue trace. This is just the ignition event. It just happens to line up with the cylinder that was bad. But I didn't pick it based on that reason. I picked it because that was the easiest one to get to. It doesn't matter, because once I know what this one is, no matter what cylinder it is, I just look up firing order and go from there.
Pick an easy hole to get a signal.
Whatever's easy to get.
Know your firing order and then count.
Just count there, right? And you know which cylinder is causing the problem. But here's what we're talking ignition. We got kind of past the compression part. Well, we're talking ignition. Hey, guess what? Look at where that's intersecting that peak. We're almost right dead center on it. Well, what's happening at that peak? That's TDC compression, isn't it?
And that's where the plug is firing.
Yeah, when does the plug fire? Just before that moment. Now, this is not measurable, can't get the exact degrees in it, but it's close enough to tell me whether ignition's timing is a problem or not. If you have a shear keyway on the crank pulley, or it's out of time for whatever reason, then you can see that very quickly, very easily with this simple little test, this simple little check. And you're already doing the relative compression anyway. So right. It's very easy to do this at the same time. Now to back up, I want you to take a look at this one. Notice here, again, here's the red trace. That's again the ignition event. This is the in-cylinder test I was telling you about. We can see where the blue peak is for TDC compression. Now you can actually see the gap between the two. That I can measure. And since it's running at idle, I can actually look up the spec for what the timing's supposed to be, and I'll know for sure right then and there. Is it right or is it wrong? Okay. So a very, very easy test to make.
Now keep in mind, when an engine is cold and it's starting, to get the catalytic converter to light up, to get it hot quick, get it working, they may overfuel and or retard spark time. So that's just a trick they've been using for a decade or more, probably close to 15 years, to get cats warmed up fast. That's how they start working as quick as they do, until we get gasoline fired, which I don't think that's happening, like in a diesel with the regen and after treatment and all that. or the electrified vehicles, a lot of PHEVs, plug-in hybrids, working on it now. I thought it was a pipe dream years ago. I walked into a catalytic converter company and seen the kind of research happening now. So look for high voltage from the battery pack. So we're taking today's world to maybe another year or two down the road. That battery pack, when it gets to a point where that engine's going to need to start, they want that cat lit off right at that moment, so we don't have to wait a minute or two and make spark retard, overfuel, the tricks that they're doing currently. We can heat it up with electricity, and that's going to hopefully bring us into a PHEV world instead of a BEV world, which is only good in some parts of the country where you have adequate fast charging stations and things like that.
Yeah, but that's a great point again you mentioned, because where we started off at the very, very beginning, ECM, emissions control module, and everything that has to do with getting the right feed gases to the cat lit up and ready to go to work, and sending out nice clean gas out the tailpipe. Everything they can do to make that happen as quickly as possible, because for that first few seconds, it's not going on. That's emissions being dumped out the tailpipe. So everything is aimed for that. Everything is aimed for that. Okay, great point. And then finally, number 4 on our hit parade is fuel. And I save that one for last because, at least for me, if I'm dealing with a drivability issue, if I can wipe out the first 3 categories very quickly, very efficiently, and know that, okay, now none of those are the problem, I'm wheeling it down to this one last little section that I'm referring to as fuel, then I can focus on that last little step. And you know what? I want you to think about, and I'm going to move to the next one here and tell you that. First, what has to happen with fuel? We've got to have the proper mixture. We've talked about that. Dave mentioned the 14.7 to 1, Lambda 1.0, that stoichiometric mix where all of the fuels combined and used and none is wasted. We have to have it happen at the right time. Again, just like ignition, the injection has to occur at the right time. That's a big thing nowadays, isn't it, Dave? Because we have with gasoline direct injection, big deal. Now, if you're an old diesel guy, then you're already familiar with that same kind of a concept of getting it in at that.
Fire the combustion event is the timing of fuel.
And the point here too is proper atomization. What if there's a restriction? And you get ready to show that, and just the tip of the injector. Is there a problem with a clog or restriction inside there that can lead to a problem in the actual atomization of the fuel?
And if you look at that, go back to that picture, if you would, Pete. If you look at that pattern, just because it's not a cone or it looks like that, it depends on the type of injector. It's not a one-size-fits-all.
Right.
Especially with GDI, wall-guided, spray-guided. The patterns look different. You're not going to get in there with a camera. Engineers do, but you're not going to get in there with a camera in your shop and look at the spray pattern. But some people, maybe with SFI, be able to put them into a little fixture. I think Launch and some others are making, and I know G had one in his shop where you can actually look at the spray pattern, pressurized ejection, put some test fluid through it. Just because if it looks different than the others, that's a big deal. But if it looks different from a different fuel injection system, don't necessarily think that that's a bad injector. And so, as they say, the baby out with the bath.
Right.
It may
Absolutely.
have to be as designed.
And it's not just the fuel. This is what has to do with what's getting in the combustion chamber. Yes, we have to have the right amount of fuel atomized correctly at the right time. But don't forget that there are the potential for contaminants in that combustion chamber. What if there's a head gasket leak? Maybe it's not enough to cause a miss or a chuggle or an overheat condition, but there's just enough that coolant getting into that cylinder to dilute that air-fuel mixture. And, of course, that's going to affect combustion, and that causes you the drivability issue. All right? Here's what I've been stressing more and more of lately. Again, mainly because of the introduction of GDI, really kind of drove this point home to me. When we're talking about getting fuel in the engine, it's all about quantity. It's all about the weight, the amount of fuel being added. You've been taught all this time, pressure is important, volume is important, and it's true. They're both very, very important, but they are indicators. They're a means to an end. The end is I got to get X amount of fuel into that combustion chamber. Why do I make a point of this? Well, in a port-injected engine, I've got all kinds of time because I can start the fuel delivery early in the process, early in the cycle. So that's why I can control the amount of fuel being added by controlling the on time of the injector. That's the pulse width that you see on your scan tool. As Dave mentioned, when the fuel demand goes higher, that goes up. And when it goes lower, it's going to go down. That's how the ECM carries out its program instructions.
Changes quite a bit from cold start to decel to load demand, things like that. But you're going to go to, I'm going to guess next, those direct injectors.
Yeah, when you're doing gasoline direct injection, when is that fuel being added, Dave?
Right before the intake valve closes, or in some cases, I believe stratified injection, when the piston's coming up towards top dead center, much like, or I should say, when the valve is closed.
Yeah.
Coming up way on top dead center, it's more like a diesel. You have to have a lot more pressure, but you can spray it in with the valves closed. Most are spraying in just before the valve closed, but with the super higher pressure. We're talking, what, 50 to 80 with SFI. Now we're talking 20 times that. We're talking in the hundreds, even 2,000 and 3,000, and what they call the 350 and 500 bar systems, which one bar is what, 100 psi or 100 kilopascals, one bar. If you go up from that, we're talking 5, 6, 7,000 psi with some of the 350 to 500 bar systems. And if I'm not mistaken, I think a Cummins needs about 5,000. The diesel needs about 5,000 psi to start. At least the old 5.9s did. So that's getting into the diesel realm with direct injection is coming your way. And obviously there's going to be some different after treatment that's just like we have with diesels on gas engines. It's already on some cars used, some manufacturers that we sell to over in Europe. And what happens in Europe oftentimes moves this way. So you might see that on that Ford, Chevy, Toyota, whatever, here in a year or two, much higher pressure systems.
Yeah, and that's, again, the point we want to make. Why high pressure? Because we got no time to get the gas in. Yeah. So if I'm going to get that increased flow through that injector, I've got to really put some power behind it to get it in there.
And it atomizes better at the high pressure.
Yes.
And it's more efficient when it's right before the valve closes or after the valve closes, like with the diesel. But the cost is we're changing pressure to change air-fuel ratio and to change the volume of fuel getting into the engine. As you said, volume is king as much as timing and pressure. If you got low pressure, you usually, almost always, I think, will have low volume. But you could have, and G actually, the very first one of these I did several years ago with you and G proved it with that, I think it was the launch little injection. You put the injectors in, SFI injectors, and he was able to prove great pressure, horrible volume. And that happens, and most techs in my classes will say, yeah, I see that. High-end techs, they'll say, I've got a volume tester. And we've had that in our manual for years, and hopefully it's not going to drop off the market, but MightyVac makes one. I think there's, you said the Mac tool truck had the one that's made by MightyVac.
Yeah, no longer sells it, unfortunately.
Yeah, they no longer sell it. But if you can find a fuel volume tester, which basically, if you go to the hassle of hooking up on a low feed line, and I've done this on a Toyota D4S engine that had both types of injection, SFI and GDI. I've hooked the MightyVac into the fuel lines with quick disconnect. You can do it. You do it anyways with your fuel pressure gauge. So why wouldn't you have a fuel pressure gauge with a long, what do you call it, the little cylinder like a mercury fix?
Yeah.
The tube that shows you the volume. The crude way of doing it, you can go to our website, the Delphi Automotive, and look at some of our tech tips. And one of them was just crude, dumping the fuel from your pressure gauge that you hooked up to the Schrader valve in the old days, or hooked in with the quick disconnects, and just dump that fuel as the engine runs into a approved container, do it safely, and look at that volume. That's kind of low tech compared to what you can do with a volume tester that actually, while the engine's running, you're not spilling fuel into a jug, you're actually watching it happen. Yeah. And about 5 to 10% of the technicians that have that tool say, the technicians that have that tool, I should say, 5 to 10% of the time say it catches the problems that are the weirdos with leanness, fuel, delivery, volume issues.
Yeah, and goes back to what we said at the very, very beginning. Again, everything's on the table when you're looking for that problem until you prove otherwise. Pressure is important. Volume's important. Bottom line in your mind as a diagnostic technician is the question you're trying to answer Is the right amount of fuel able to get into that combustion chamber? Is it getting there at the right time? Is it getting there properly atomized and free of contaminants? These are all under that one category, fuel. And because there are so many small variations that can make a huge difference, that's why I save that one for last. If I can verify that all the other three are fine and where they need to be, then I know it's got to be in that last little category, and I can focus my efforts on that.
Exactly.
And that's
fuel, let me just add something like that.
Sure.
Fuel volume is like current flow. That's
True.
doing the work. Voltage is like pressure. Well, you could have 60 pounds of fuel pressure, but if you don't have that right flow, at least a half a gallon a minute on many of them, you're going to run into a problem.
Yeah, absolutely.
And
Absolutely. So
you guys that seen that camera go all the way out to the back of the shop, that is the fuel volume gauge
that you guys use here, right? Yeah.
that we use here all the time. And what's his name?
Bill?
No. Dave. I'm trying to Dave.
Yeah. Hey, he's sick, guys. So we'll cut him slack.
That Dave was referring to. Sorry. Back to the regular schedule.
So again, just to recap, when you're looking at those fuel issues and you're not sure it's getting the right, you got to go back to what we said earlier about how the ECM works. It's programming. It's going to deliver that amount of fuel based on the parameters that the software engineers set. RTFI, read the information, understand how the system functions, how it operates. Many things that Dave mentioned about these various different systems, you're going to find by just taking the time to look at the information. If you just go off and just shoot from the hip and treat it like you've treated every other car you've ever worked on, and you get some late model GDI in your shop, you're going to have issues. You're going to create problems for yourself and for your customer that there's no need for you to do. Take the time to read the information. Look up those technical service bulletins. Do the easy stuff first. You may find the answer to your problem right there. Maybe it's a change in programming. Maybe it's an updated component. Whatever the case might be, always go there first. And next, check the sensors. Is the data being sent to the ECM so it can make the correct decisions? Is it true? Is it accurate? Does anything look like it's out of whack? We're going to show you some of that when we get over to the car. And then, of course, once we verify it's getting the right information, are the injectors working? Are the actuators working in the system, doing what they're supposed to do? These are all things we're going to look at. Just a few examples of critical sensors on the fuel side. You have a load sensor, something that's going to let the ECM know or let the ECM have the information it needs to calculate the amount of air getting in there in the first place. Of course, the temperature sensors play a part in that. Cam crank sensors, where is the piston and valves in relation to each other and to the injection event? Is the VVT system functioning correctly? And then fuel pressure sensors. Now you have GDIs, you have a low side and a high side. And just to kind of go real quick on what Dave was saying earlier, NG, when you're looking at the low side, that's okay to look pressure and volume. Don't be cracking open and try to hook your gauge up to anything on the high side. Again, we're talking about pressures at a minimum of 300 or 400 or 500 PSI.
I'll plug my video. It's on the Delphi YouTube channel. It's just Google Delphi high pressure GDI depressurization. Big word.
Yeah.
Lower safety with GDI Delphi. Put those words in a Google search. Yours truly, I think we got it down to 5 minutes. So it's in my dad's old shop. You can see an old Mac toolbox in the back. And I had a banged up thumb when I did it. It wasn't from blowing a hole through it with that high pressure gas or diesel fuel leakage. It was from another dumb stunt with a car door, all right? But you know what it's like to work with an injured hand? Well, try working without a hand or an arm if you get blood poisoning at that high pressure, the 100, 300 bar, now it's 500 bar system's coming. What are we at, 150 bar now? That's like 3,000 PSI. That'll split through you like a pressure washer with a cutting tip.
Yeah.
And that. Forget stitching up. That's one thing. All right. Ouch. They're going to be working with a bummed up hand or whatever for a while. It's the infection. It's called blood poisoning. And it typically can result in an amputation of a hand, a digit, a hand, or whole arm. So you don't want that. Obviously, wear safety glasses. So I don't just warn you about the safety factor in that video. I tell you how to depressurize. A couple generic ways of doing it. one with the scan tool, one pulling a fuse. So watch the video. If you're ever in doubt, don't know how to depressurize a high pressure GI system, some will remain pressurized like the next day, still keeps the pressure up. Or you touch a door handle or something like that, and it comes up to life. So you want to watch the safety side of that.
Absolutely.
So back to this, the lying PIDs, all right? These guys in cuffs, I guess they're the liars.
Yeah, they're the liars.
Like the guys that stole my suitcase here about a week ago. Lost a lot of equipment. Speaking of pressure transducers. So yeah, it looks like the cops getting ready to take them in. So what do you do with lying PIDs?
Well, this is the thing, guys. You've heard G and I say this more than once. If you're doing drivability, the first scan tool you want to grab is your global OBD2 scan tool. And there are a number of reasons for that. First, if a vehicle is made for sale in the United States, it has to meet certain standards, OBD2 among them, which means that I don't care what the nameplate is. If the check engine light is on, if the engine's not running the way it should, I'm supposed to have the information I need to fix the car in that global OBD2 mode. And if you looked at it, you see in later model vehicles, the data PIDs have just grown and grown and grown. You have the information you need. I know as a working tech, I probably fixed 98% of the drivability issues I was faced with nothing more than a good global OBD2 scan tool. Another reason for that, of course, the connector is standardized, meaning the code definitions are standardized. But here's one you may not have run into. The data that you see on the scan tool has to be correct, has to be what the sensor is actually reporting. Well, what do you mean by that, Pete? Isn't that true across the board? No, it's not.
Wait a minute, Pete. I thought it would say 0 volts or 5 volts.
Well, that's the key. If you know that number, Dave, and a lot of techs rely on the reading of the sensor in temperature, pressure, whatever it's normally listed as. For example, let's just take one that's the easiest one for you guys to prove this out for yourself. If you go to enhanced mode in your scan tool and you start scanning the data list right off the bat, looking for that odd man out to see if somebody is not telling the truth, and you get to that, I don't know, the engine coolant temperature sensor, and it's reading 167. And you're thinking to yourself, wow, that's a decent number. And you go, continue on with your trials.
Bite you like what negative
40.
Negative 40
right.
Or 300 positive.
Right.
You go, there's no way this engine's that hot or that cold.
Yeah. And what Dave's alluding to here is if you go to global OBD2 mode for that same failed sensor, you may see one of those two numbers. You want to prove it out to yourself. When you go back to the shop tomorrow, do this. Take a customer's car in, set it up for enhanced mode if you have that available on the scan tool. Look at the ECT reading and unplug the ECT to see what it changes to. Odds are it's going to come up with another value other than minus 40.
It's a made-up value. I like to call it fail-soft. Software, instead of fail-safe, it's fail-soft. We plug in a number based on other parameters, other sensors, and come up with a guesstimate, basically a virtual sensor for the sensor that's not working right. And before the light comes on, and it may be holding off to do a 2-trip code or whatever, if it's a little bit off with what I think you're called the rationality test.
Yeah.
Then we're going to finally flag a code. But before you does flag a code, the no code drivability symptoms, hey, 167 sounded good to me, Fahrenheit of coolant temperature. But what if it's actually 140? I may need a little richer mixture with that extra dense air that 140 would be, or 99 and it's showing 130, something like that. A little mistake. Didn't you say that earlier? Just a little bit off.
Can make a difference
on today's engines.
Yeah.
So where are you going to find the real answer?
Yeah. And so if you see that, if you go and look at global OBD2 mode, again, with the same parameters, ECT unplugged, well, then you're going to see that minus 40 degrees typically will be the reading that you see. But as you pointed out, if you're familiar with the voltage output from these sensors, then you're going to see either the close to 0 or close to 5 volts range when if it goes open or shorts to itself.
So to use a metaphor here, and I used to be in law enforcement, and unfortunately, it gave me a little pessimistic attitude about perpetrators, okay? These guys are actually suspect, guilty, or innocent until proven guilty. However, the cops usually arrest the right people, usually. So let's say you arrest them. From experience as a law enforcement officer, they will always lie. There's never any guilty people in prison. They're all like, I'm innocent, all right? How do we give these guys the truth serum? The truth serum is OBD2 Global, a place where a lot of you technicians don't go, but a lot of you sharp ones are going there and going, yep, I go there as much as I can, either because, like you said, it's not I can't see the forest for the trees.
Right.
Too many PIDs. This is indelicate, so I'll apologize in advance. PID diarrhea, I call it. Too many PIDs, all right? Now you have a finite group, and with CAN bus data streams, I've noticed it's like 40, 50 PIDs. It's a decent list. It's not like 10 anymore with the pre-CAN bus days. So now we have a decent list of PIDs. It's not overwhelming with stuff that's not germane, like, what is the position of EGR or whatever, what's the cam timing. I want to know the basics, the things you were talking about. Spread those 4 points out. Air volume, air sealing, that split the air, fire, fuel a little bit down with the air and the fire and the fuel, the ignition and fuel. I want to look at those main things and come up with some of those actuator outputs. That truth serum is in global OBD2. On CAN bus vehicles, it's very deluxe. A lot of info. Don't overlook it.
Yeah, and not only for the live data, the global OBD2 has actually 10 different modes or resources available in the tool that can help you with your diagnosis. Again, I said this before, you're here on the site now. You have access to the entire library, and we've done webinars explaining the 10 different modes and how to use them. Mode 6 is a great place to look for test information. Just a lot of resources to you there that I want you to make sure you take advantage of. So check out those webinars and learn more about the power that simple little global OBD2 tool has for you. All right. Now this we kind of harped on again. I'm not going to kill it another time, but again, I got to stress, look up your technical service bulletins, RTFI, make sure you read the information. Critical actuators, we're looking at nowadays, we have to worry about the fuel pump module and its performance. Many cases, GDI, we've got 2 pumps. We've got the conventional style pump, low side, what we call low pressure now. A few years ago, that was high pressure, but now it's kind of junked down, right? So, and we have, of course, the high pressure pump, and now the injector type and types, right?
And on some vehicles, Ford and General Motors, now Ford uses just a digital signal from the fuel pump control module to tell the PCM, hey, okay, I'm all right. And then it does the pulse width modulation to the fuel pump. General Motors, on the other hand, even before the GDI days, on some vehicles, had a CAN bus controlled low pressure in tank fuel pump control module. And it had a PID for fuel trim. And then there was another PID in the ECM for fuel trim. So 2 modules were doing trimming of the fuel. The ECM was trimming the injector. This was SFI. And those are still out there and they're in your bays being worked on. And then the fuel pump control module had a PID from the ECM to control what the fuel pump control module is doing, which was another trim. So 2 trims, injection trim and fuel pump output with varying duty cycle. So those were some things that you need to make sure you don't overlook in the PID list. There's where you may need to venture outside of OBD2 Global and go into the enhanced data and look at those. So don't overlook fuel pump control module, fuel trim.
Yep. And how are you going to understand all of that? RTFI. Yeah. Now, I got the oxygen sensor here separate. Now, this can be either conventional or wideband sensor. Yes, it's a sensor, but it's not providing direct information to the ECM that the ECM is going to use to calculate its fuel. Well, not directly. The oxygen sensor's job is to let the ECM know how it did in its calculation. It's a feedback. And there are other similar systems in engine management where there is some type of feedback input that lets the ECM know. Yes, closed exactly. That's where the closed loop comes in from, is that they're working in tandem and everybody's happy. And we're not going to need a big diatribe on oxygen sensor operation. Let's just say that it cannot tell the ECM exactly how much air or fuel mixture passed by it. It reacts to the oxygen content. Even the wideband sensor does the same thing. It's a lot more responsive, but it still does the same thing. If you have a conventional sensor, you've seen that switch on a data graph, whether you put it on a scope or you watch the graph mode on your scan tool, you know it switches back and forth. Wideband sensors do the same thing, except you really can't see it on most scan tools. Some have a current side because that's where the switching is actually occurring. Yeah, but the voltage side, you'll usually see at an offset based on manufacturer, and it remains pretty stable. The main thing I want you guys to understand right now, again, is that the oxygen sensor is merely telling the ECM, hey, you either hit it lean or you hit it rich. Why do we have to go back and forth? because again, the sensor can't actually read what's passing by it. It reacts to it. So in order to get that fuel control, we've got to make it go a little above where we want it, a little below where we want it, and back a little bit above. And once we see that, if you go compare that to your short-term fuel trim numbers, well, you're going to see those do the same thing in reaction. When we go a little too lean, we go a little too rich on the short term. When we go a little too rich on the oxygen sensor, we go a little too lean on the short term. And that's what gets the thing to bounce back and forth. That's what you're seeing reaction. Again, we're talking about fuel is that fourth pillar. If I see short-term fuel trim running about plus or minus 5, I'm very happy.
Yep.
And the ECM is very happy. If the ECM's happy and the catalytic converter's happy, I'm happy.
Single digits.
Yeah, single digits is always good. If I see up to around 10-ish or so going either way, well, I'm going to kind of look at the oxygen sensor. If it's got some miles on the car, maybe it's getting a little tired, a little old, not quite as fast as it used to be, like me. So maybe we need to do something with the sensor there. Take a look at that. And then beyond that, the corrections are going to be outside the range that the software engineer wanted it to go. And it's going to have to do the learn value that we get to long-term fuel trim.
Before it gets into the 20s, you'd be surprised if you look at some of the parameters. You can find out some of these numbers in mode 6, like what are the ranges. Fuel trim, how wide it can get, how far above or below 0% it can get. It's amazing what it takes sometimes to turn the mill on.
Yeah.
But you have a drivability problem.
Long before that happens. Yep, absolutely. All right, moving right along. Testing fuel delivery, we've talked about that. Conventional methods that you're familiar with your fuel mechanical gauge or the volume tester. But what about looking at a fuel pump using current? A lot of you guys who use scopes are already familiar with this. This test has been around forever, but I still meet individuals who are new to it, and that's cool. Again, that's why we're here.
Yeah.
Now, this isn't just an electrical test. I can tell a lot about, again, what it's doing. If it's a motor, what's going to make a motor work harder? When it has some type of more work to do, maybe a restriction. So if I look at the overall current, say in this case, we're right about 5 amps or so. So if I see it higher than it should be, well, then the pump's working hard, right? Something's causing a problem on that side of the system. If it's really lower than what it should be, well, maybe the pump ain't working so hard. Dave, is it possible for a fuel pump to run out of fuel, but there's plenty of fuel in the tank?
Because of a restriction.
Yeah. And you guys know all about that. In fact, I got to tell you what.
The tank.
Yeah, I mean, and it's like there are several filters in that pump module. I think it's like 5 or 6 before it even gets to the line to the front of the engine.
Filter in most injectors.
Yeah.
So you've got the sock or the strainer, and no matter if you don't even see it, it's probably in the bucket, the modular fuel pump assembly. Then you've got the internal lifelong filter. We're talking days after. What was it, the late 90s or whatever, when we moved away from return systems where the fuel went up to the rail, the fuel pressure regulator said, I don't need that much pressure. I'm only going to use a fraction of that volume. I'm going to drop the pressure. I'm going to send the remaining back to the tank. And by the way, if you go to DelphiAutoparts.com, just put Delphi Auto Parts, Delphi Automotive, you'll find our webpage. Click on catalog, and then click on a fuel pump part number. Just pick one. And then you can look at information. So there's pictures and so forth of the pump and what it fits and so forth. But look at information. Information will give you system pressure. Like 90% of the time, we've got that spec right there in our online catalog. And then look at gallons per hour. That's important in current draw. So those numbers help determine what's going on. Now the gallons per hour will blow your mind because they're typically somewhere between 22 and 30 some gallons per hour.
Wow.
That means you drive whatever you're driving, or you drive this little rental Honda, in an hour, you've moved all the fuel tank up to the engine and back. Now that was the old days. Since the 90s, early 2000s, we went to returnless systems. Now all that fuel is being circulated within the tank. Either way, it goes through an after the pump filter. On the old days, the fuel rail filter was replaceable. You guys all put those in, with the old tune-up days, or maybe you just did it after the tune-up days. It was a preventive maintenance thing. Now it's built into the tank. It's got several times the media to filter, but what if even the biggest fuel filter can't filter out garbage? And we got a lot of information out there on our website, on also other webinars that we've done. Make sure you check out the whole fuel tank contamination issue. In fact, I just wrote an article, I think it's coming out next month in Motor Age, about fuel tank contamination. And I wish I'd had more words, and Brandon would have let me put more pictures and words in, because there's a lot to that story.
Yeah.
Make sure you're boned up on that. Don't absolutely say, I don't care if it's our pump or some other brand. If it's failing one after another, it may not be a problem with the pump. It may be another issue, electrical or fuel tank contamination. Just because you pull it out and you don't see a whole bunch of garbage in that hole where that tank, sits, if you didn't drain the tank, or if you drain the tank, just because it may all be in the filter. Your carpet may be clean at home, but if you're the one running the sweeper, or your spouse, whatever, and they're a clean freak, and 30 gallons per hour is a clean freak running that fuel through that internal fuel filter, the dirt may be in the filter and it'll die. You'll have a restriction after the pump. When the restriction occurs after the pump, that's more work. It's trying to blow through a straw, and there's a restriction on that straw. You're getting blue in the face. That's a lot of work. So the current goes up, and that's widespread, clear across all these brush to commutator bar pulsations you're seeing here. That's what you're seeing, brush to commutator bar. As the armature turns, you see these fluctuations. So if the current draw is way too high, those specs are in our catalog. They're also probably in Mitchell All Data, Denifix, the places you look for service information. But if the pressure is lower than specs, and the current draw is lower than specs, that may not be a upstream filter in the fuel pump modular assembly or the old fuel rail filter or kink line. That may be cavitation, low on fuel. The strainer is partially restricted, or Pete, what's one other thing that can make the current lower?
It's not running on anything.
Or one more thing,
ED.
Electrical, a voltage drop.
That's it.
So if you're getting insufficient
Very good
current, you're getting a voltage drop, it causes a drop in current to the pump will run lower speed, lower pressure, and the current draw will be down. But you'll see consistency, but I'm sure you're going to talk about the inconsistencies you see here.
Yeah, and we're just going to, again, just a teaser, if you will, show you these different techniques that you can use for these different pillars. And as he was pointing out, you can see that this is not uniform, which indicates that there's some mechanical wear between the brushes and the commutators on this brush type pump. Now, this pump may be working just fine. Good pressure, good volume. But Dave, you and I flew here. If I knew that pump pattern was on that airplane looked like that, I think I'd be taking a taxi home, right?
Yeah.
Because it's going ready to fail sometime, and we don't have a crystal ball. But guys, again, we're here as professionals to help our customers take the best care of their vehicles that they can and to keep them safe. I don't want my wife on the side of Interstate I-4 during rush hour in a stranded vehicle, and I know you don't want your customers there either. So if you did a test like this and you saw indications of a bad worn pump, and you'll get this by looking at a number of them to know what known good is, then I have no qualms about recommending that repair to my customer. And as we said right again at the beginning, and we'll say it again, you either fix it right or you fixed it wrong. There's no gray areas anymore. As Dave pointed out, very common cause of pump failures, and the pump gets all the blame, is because there's stuff in the tank that wasn't removed or cleaned during the repair process. And I'll tell you something else. Delphi is a big help on this. If you drop Dave a note, they make a great little cleaning kit. It's a cleaning solution and cleaning wand with tips to go on the end of it. And I'm sure that Dave would be able to help you, hook you up with that and help you do the job right.
You got plenty.
Got plenty, right? Okay. Before we move on to this little last part there and for the presentation itself, there's one other thing I want to cover. We talked about injectors. You know, one size does not fit all. I had cases where someone put the wrong injectors in a vehicle and that caused the fueling problem. But now GDI, piezoelectric injectors, if you're removing them for service, you got to make sure you put them back where you got them from, because they are coded for that cylinder. If you move them around or replace them, you have to tell the computer the new code for that replacement. And I tell you what, if somebody starts messing with your stuff in your bay while you have a system like this apart, and they swap them around for you, trying to find that fueling issue caused by that, that's going to be a challenge, right? That could be a real challenge. So these are the nuances that if you did I hear somebody say RTFI?
CFI.
Yeah, if you didn't read the information, you wouldn't know these things. That's why we're stressing some of these things for you guys and gals. You're again preaching to the audience. I know you guys and gals who are watching tonight. You have talent, you have skills. You wouldn't be here if you didn't. But we all don't know what we don't know, right? So that's our job, is to point out some things just for you to consider, think about, and then take back to the shop and put to use to see whether we're right or not, okay? Now, here's one of those examples. We're showing a brush-type fuel pump, current waveform, and I'm sure that if a lot of you guys came in with a no start and you wanted to see if the pump was working, you might be either listening for it running in the tank, or maybe you would pull out an amp clamp or your scope to see if there's any current flow through the system. Well, if you decide to replace the fuel pump and it didn't work, this might be the reason why. So we'll focus on the screen there and we'll play this little video for you.
If I were to ask you, how do you test this fuel pump? What would you tell me? Would you say, check power and ground at the fuel pump connector? Or would you say, remove the relay and bypass the relay to see if the pump comes on? Or would you say, break out the scope and do a current ramp? Well, if you did any of the above, you're well on your way to replacing a fuel pump that likely isn't bad. Learn what I mean in today's Service Done Right. Today's episode of Service Done Right is brought to you by If I were to ask you, how do you test this fuel pump? What would you
Sorry
tell
about
me?
that. If I made a mistake, I'm like,
Would you say,
it's like
check
the
power
PowerPoint
and
pushed the
ground
wrong
at the
damn
fuel
button.
pump connector?
Sorry.
Or would you say, remove the relay and bypass the relay to see if the pump comes on? Or would you say, break out the scope and do a current ramp? Well, if you did any of the above, you're well on your way to replacing a fuel pump that likely isn't bad. Learn what I mean in today's Service Done Right. Today's episode of Service Done Right is brought to you by Delphi. Be sure that you visit their website at www.delphiaftermarket.com. You've determined that the cause of your customer's drivability concern is a result of low or no fuel pressure. And if you use any of the methods that I mentioned earlier to test a brush-type pump, then you would very quickly determine the cause and needed correction for that concern. However, if you tried it on this pump design, you're going to find yourself going down the rabbit hole and replacing a pump that didn't need to be replaced. Why? That's because this is a DC brushless motor and it works completely different. But before we get into the details of how this works and how to test it, let's review how a conventional brush type pump operates. There are numerous components inside the pump housing, including the permanent magnets attached to the inner case and a rotor comprised of coils of wire, typically 8, that terminate at commutator strips located at the top. 2 carbon brushes, one supplying system voltage and the other ground, are in contact with the commutators 180 degrees apart. These commutator strips are the 2 ends of one of the individual coils. When the circuit is closed, current flows through the winding connected to the brushes and a magnetic field develops. The poles of this field are in opposition to the poles of the permanent magnets, and the two try to push away from one another. This begins the rotation of the rotor. Of course, as the armature rotates, it quickly breaks the connection for that particular winding, but it's almost immediately replaced with another winding's connections. And this helps to ensure that the magnetic field strength remains relatively stable. A brushless DC motor, in its simplest terms, is a brushed motor built inside out. The permanent magnet parts of the motor are located on the armature, and the windings are now attached to the outer case. In the case of the 8 windings that we saw on the brush type motor's armature, this stator only has 3 coils connected in either a Y or delta winding, similar to an alternator stator. In addition, the wear items, the commutator strips, and the brushes are gone. A dedicated fuel pump control module pulses voltage through the 3 stator windings in sequence, 120 degrees of rotation apart. The end result is the same. The rapid buildup and collapse of the magnetic field in the 3 stator windings creates that opposition to the permanent magnets on the rotor to get the rotor to start turning. What do you say we take a look at what the test results might look like on a DVOM and a scope when looking at a brushless DC motor? So let's start by looking at the schematic. Now, I'm sure that you've seen 4-wire connectors at a fuel pump before, so that alone is not going to tell you whether it's a brush type or brushless. However, on this one, there is a clue. If you look at the first 3, the black, green, and blue wires, they're labeled W, V, and U. And if you're familiar with hybrids, that's the same way we distinguish between the 3 phases of a motor generator. So that's a clue. Now, we say we hook up a DVOM to one of the wires and see what kind of reading we get. All right, I've got the meter connected. So now I'm just going to turn the key to the on position, or in this case, it's a smart key. So we're just going to hit the start stop button. The on position. And we have a reading of 12.8 volts. So we got a fully charged battery, number one, we know that. And that, if we were looking at either a brush type or brushless pump, big difference though. If we had a no start condition related to fuel and you were checking a brush type pump, you may look at the connector wiring and say, okay, well, I've got voltage to it, so that's not the problem. But in the case of a brushless pump, that's not a good reading. There is no signal being sent to that pump. So the brushless pump may not be functioning at all. Let's see what happens when we start it up. You can see the voltage is now dropped to 6.9 volts. If this was a measurement that you took on a brush type pump, that would be indicative of a problem, wouldn't it? And you would probably raise your eyebrows at that and go looking for a cause of voltage drop. However, on a brushless pump, this is a normal reading for a pump that's running. How are we going to know for sure? Time to break out the scope and see the differences in the patterns. So now I have the probes for the scope attached to the fuel pump. I have a probe going into the UV and W wires, and I also have an amp clamp around one of those wires. Try to look at it with the ground, nothing coming across the ground that's usable. So if you were to try to do a current ramp on the ground wire and you saw that, you would suspect the pump is faulty. I want to show you that's not the case because we're looking at, again, at a brushless pump, and there is a huge difference. So I always like to share how I set the scope up to get my first capture. It always has served me well for 95% of the scope captures I want to get. At least it gives me a starting point. And what I mean by that is we're going to start with what's called the 20-20 rule. And what that means is I'm going to set all my channels that have the UVW leads attached to 20 volts for the suite. And this will cover just about everything on a 12-volt system, right? So that's the first 20 of the 20-20 rule. I'll leave the amp clamp where it is for now. And time is the other. It's 20 milliseconds per division. That's about the amount of time it takes, or the 200 milliseconds across the screen is about the time it takes for a 720-degree rotation of the engine at idle. So I'll get something on the screen. It may not be perfect, but it gives me a place to start. So with that being said, let me start the engine, and we'll see what it looks like. So I've got a pattern on the screen, but it's pretty much useless the way it is. We need to kind of fine-tune that a little bit. So let's start by increasing the voltage. That will cause the pattern to shrink down a little bit. And we'll change that on all 3 of the UVW channels. And now I have something I can manipulate a little bit. So let's just kind of separate it. And we'll bring one up. We'll bring one down. And then the only one I have left is the current. We'll bring that down below. Okay, now you see something interesting already on the current pattern. Notice how the current pattern is going positive and negative. That's an important distinction I want you to keep in mind as we proceed. Still a little wide, a little hard to see, so we're going to do that, change that by adjusting the time base. If I lower the time base, I make it faster, I can spread that out a little bit. Let's go down to 1 millisecond. Probably a little too much there. 2 milliseconds. That looks pretty good. And we're going to go ahead and stop it right there so we can take a look at it. So here's what you see here. You've got the UVW feeds to the fuel pump. And again, this is a stator, a 3-winding stator, and it's on the outer circumference of the case. And then, of course, there's a permanent magnet rotor. So how are we going to get that rotor to turn? Well, the permanent magnet has north and south poles, correct? So I need to make a north pole, a south pole, a north pole, a south pole, in order to turn that pump through that 180 degrees of rotation. Now, if I had enough momentum, that's all I would need, but I don't. So I have 2 more windings in 120 degrees opposition to one another in order to keep that rotor moving. But what I want to stress again is positive, negative, positive, negative. How do we know that? Look at the current pattern. Negative, positive, negative, positive. So we're changing the polarity through the winding. For U, then V, and then W. Changing the polarity changes the poles. Let's just say north-south, south-north, north-south, south-north. And that is what's keeping that in opposition to the permanent magnet poles and keeps the fuel pump spinning. If you were to look at this and there was a problem with one of the windings, then you would see a problem in the amplitude change. If there was a short in the winding, for example, the amplitude would be lower on the affected winding, and you would be able to see that here on your scope capture. If it was a problem with no signals being seen at all at the fuel pump, well, then I would be going to the fuel pump control module. Is it getting the information it needs? Is it sending the signal out? Is it some break in the wiring between the two? Or is the fuel pump control module itself? These are just a few things you want to keep in mind when you're troubleshooting a brushless type fuel pump. And then completely different from a brush type pump. Don't let those initial readings throw you. Make sure you look at the schematic and identify exactly what kind of pump that you're working on. Here's another example of the brushless fuel pump waveform taken at the fuel pump control module. Remember, where you take the capture, what type of scope you're using, and whether or not you use a low-pass filter can affect the pattern you see on the screen. And while this one looks much different, you can still see the 120-degree phasing of the UVW windings and the current polarity changing. And just like the one I showed you earlier, if a stator winding has a problem, you'll see it here. Now, if you do determine that the fuel pump needs to be replaced, make sure that you perform a critical but often overlooked step, and that's to clean the tank before you install the new pump. Any debris that you leave in the tank could lead to the early demise of that brand new pump, no matter who the manufacturer might be. And Delphi has actually come out with this really cool little cleaning wand to help you make sure you can clean the tank thoroughly with a minimal amount of trouble. In fact, I will leave the link to the wand in the video description so that you can get a few for your shop. Like I said, it makes it very easy. You can replace the ends, and then you can get in with your cleaning mixture and get way down inside the tank with no problem and get everything scrubbed nice and clean before you put that new pump in. Again, don't overlook this critical step if you want the job to be a service done right. And when you're considering a replacement pump, choose a Delphi pump. After all, they are a tier 1 manufacturer and they supply parts to the OEMs as original equipment. So why not choose the same for your customer's aftermarket replacement? If you'd like more information about the line of Delphi products, be sure to visit their website at www.delphiaftermarket.com. Well, that'll do it for this edition of Service Done Right. Thanks for watching.
All right. So I want to make sure you get that exposure because, again, a lot of vehicles today are using these brushless type pumps. And if you don't take the time to RTFI and look at the schematics, you may find yourself replacing a pump that didn't need to be replaced.
I want to add a little bit to that RTFI. Okay, so the read the freaking clean it up G-rated version information, that implies the service manual.
Yes.
Or aftermarket information. You know, this stuff right here that you demonstrated and that pattern I got, that was in my driveway, a true DIY during the COVID lockdown. What else are you going to do? You got to get on your back, work on a vehicle to see what makes it tick. I was using Pico 5. And was it 6? What's the latest one? 6?
7.
7. Okay. So I had 7, but I wasn't using it. I was using 6 because I was more comfortable with it. I got the pattern. It was a little scratchy. I couldn't make sense of it till I turned filtering on. Pete's doing the same thing like a year later in his shop, and you saw that video. He's using Pico 7, and he couldn't get my pattern, even turning filtering on, because the filtering was different. Just a quick auto filtering. And I finally figured it out because you were frustrated trying to get my pattern. I was frustrated trying to get his pattern. And it was like that Budweiser commercial, great taste, less filling, great taste, less filling. It doesn't matter. We both finally got the patterns the same. Whether you see some of that noise and the pulse width modulation or you see the basic root signal is irrelevant. The fact that you're having trouble, and you will, I guarantee it, with 3-phase motors, I'll call it having trouble coping with new technology. If you're having trouble coping, it's time to start scoping. Not exactly fretting over exactly what you get, but the fact that you started scoping. I want to make that concept plain, because if you used a meter, if you want to just Google Delphi 3-phase fuel pumps, you'll see a similar video, only a shot outdoors, not as nice as yours. I was just like, an engineer friend came over with the phone and
it works.
Yeah, it worked. But the whole point was the meter was worthless. Even with the frequency counter turned on, a high-tech fluke meter, I had to get the scope out. And it's not the 5 volts to 12 volts you'd think. It was a lot of different numbers. They vary. Why are we beating out dead horse? Because on fuel pumps, it's the only product I'm aware of, and I see a lot of electrical schematics, where the 3-phase wires travel some distance, and that means you got to deal with connections, rodents damage, vehicle, hitting things, that kind of
corrosion,
stuff. Yeah, corrosion. With you got a 3-phase blower motor, and they're very popular. You just don't know it. You've got power, ground, and Lin. Power, ground, can, and it works. You either got the power of the ground and the signal, and it works, or it don't. You don't have to worry about the 3-phase mumbo jumbo. You're working on a new Sienna minivan, for example. The fact it's a hybrid is irrelevant. They put the fuel tank where you think they put it, and the pump in the tank, obviously, duh. It's a GDI system. It's actually a 2 GDIN SFI. That's irrelevant. Still got a low-pressure pump, like a diesel has a lift pump. GDIs have lift pumps, if you want to call it that. The fuel pump control module, guess where? Left kick panel. Yeah, that's right, up front, driver kick panel. All that wiring goes to the back. You better have your ducks in a row when you're diagnosing wiring issues. If you use those power probes, eeny, meeny, miny, mo, U and V, and terminal number 1 and 2. I'll put power and ground, power on one, ground on the other. You might just burn some wiring up, or the pump.
Yeah.
So following up on that, but that's not in the service manual that well. I looked at that factory schematic. I looked at some aftermarket with some other brands. You know what I've noticed service engineers are really into? The ohm meter. Like, ohm the circuit. That's great. If it's an open circuit, you caught it.
Right.
What if it's not? What if it's got interference? What if it's a partial open? It's got a voltage drop on it. There's where you need the tools, and then not just the manual RTFI, but we could change that acronym to get in a freaking training class. What's that acronym? RTFC.
GINFRIC,
right? So beating that dead horse, you're in one now. I want to actually continue that.
Yes.
And get your buddies, involved, because it is definitely not going to be a power and ground world like it used to be.
Right, and that kind of raises some interesting points too. I was just thinking about it. If any of you guys have been have some hybrid training behind you, you might see some similarities between something else that the motor generators. Yeah. Same type of thing, but much bigger.
Shocked off the 3-phase fuel pumps,
right?
But orange cables.
I do want to point out that even though Dave and our original patterns were what at first appears to be light years away from one another, they really weren't. You can still see the AC cycle on all the 3 stator windings, and you can see definitely on Dave with the higher peak in the current. You can definitely see the current going positive, negative for that stator winding. So that was still there. I think the main thing that you could see with mine, with the no filtration on it, was the actual pulse width on-off that the module was applying.
They call those electric motors that have 3 wires to them, and more are coming.
Yeah,
guaranteed. A little insider info warning to you. They call them BLDCs, brushless. That's a good thing. You have to worry about brushes out, therefore you won't see that pattern you used to see, and they'll last longer. The bad news, it's not DC, direct current. Yeah, that's what powers the module that controls it and pulses those 3 phases. But the actual, as you've seen and you mentioned, the AC element of the waveform. And actually, I saw AC on my meter. If you look at the other video that's out there, it is a weird little thing. And that's why we're here to help with all the weird stuff that's going to turn into, well, this pump went bad. And I found out recently, not ours, but the OE for that one manufacturer that's using a lot of them, they had a lot of problems and they had a recall, but it wasn't because of electrical issue. It was a good old fashioned binding bushing or something like that. So the basic stuff and the basic faux pas of any supplier, any OEM manufacturer, and the parts that will come in the door is still going to happen. You know, a tight, out of spec bearing, bushing, whatever, as well as weird stuff with modules and grounds and circuits. And that's where it's going to get into your world to figure out which it is. When it's got a recall and they explain it well, or there's just a one-off in your shop and you got to diagnose it.
Yeah. And
question, guys, I'm sorry, Bill had a question
please.
here.
Yeah.
What is the link, or how did they get that Delphi WA?
Oh,
They email you?
yeah, just email me, D.A. Hobbs, Hotel Oscar Bravo Sierra, my last name Hobbs. D is in Delphi, A is in Alpha. D.A. Hobbs at BorgWarner.com, BorgWarner, like the Borg Warner Trophy at the Indy 500. And I'll get probably way too many emails. That's fine. I got a bunch in my garage. My wife will appreciate it if you help me clean out my garage a little bit during the test. Like,
no worries.
Like, help him get rid of the stuff in his garage. So I'm sure
BorgWarner.com.
We got more at headquarters, obviously in Auburn Hill, Michigan. But yeah, send me an email with your address and make sure you put on there clearly your address. You watch this broadcast, and we'll get one mailed to you.
Yeah, and I'm sure that if for some reason you misplaced that one, you know how to get a hold of me and G. We will more than gladly pass that along to Dave so he can help you out with that.
We'll be giving them away at the big event, won't we, Jim?
That's right.
There you go.
TST big event. Yeah. Give them away.
So still, boy, I tell you what, man, we're just cramming it in on you guys tonight. So we have still got some more to get through. Another thing that comes to that fuel pillar is the injector balance. Is each cylinder getting the fair share of that fuel delivery? The ECM does this calculation, and it doesn't distinguish between cylinders, at least not yet. You know, I'm sure that's coming down the road. But right now, it just says, hey, this engine needs X amount of fuel. You guys divvy it up among yourselves. And so that's why the injector balance becomes a critical issue. Now, back in the old days, we got the mechanical gauge out and little clicker, and we had to go through all this hoopla to get it, just a pain in the butt. Again, with the scope makes it so much easier. That's what you're seeing in this diagram here. The green trace here is a pressure transducer. In fact, it's the same one that I used to do the in-cylinder pressure test, just set it at a different scaling, and it's connected to the fuel rail, and the engine's running. Now, I have a reference. I have injector number 1 just to tell me when everything's going on. So let's see. I've got 1, 2, 3, 4, 5. I've got 6 peaks. So I must be working on a 6-cylinder engine. And here's what I'm looking at. I'm looking at where the base of these valleys are across those lower amounts on the lower part of the graph. This is where that's the drop that occurs in pressure across each injector. That gives me an idea of whether or not they're flowing equal amounts of fuel. Now, what about this little hazy looking little thing? Well, that's ringing in the rail because it's consistent between that one, and that one, and they're all on the same side of the engine. That's nothing. I don't worry about that. How are you going to know it's not a problem? Again, you do more than one. If there was a pressure difference, if it was an injector that wasn't opening, for example, I wouldn't see the drop at all. So that's what I'm really looking for when I'm looking at that particular method. And that's not the only tool you have. Again, with GDI engines, you can't tap into the high side to do any kind of direct test on those injectors. You can look at the scan tool, but you look at the total fuel rail pressure. But again, I'm a scope guy. I figure if that sensor can tell the ECM what's going on, it can tell me too. So try that. Connect to that sensor signal and that high pressure rail sensor to your scope. You'll get a similar pattern showing you, that one, showing you that drop across the injectors.
You said you had a 6.0, and that's a diesel.
Yes.
And it has cylinder contribution, power contribution, right? But not just cranking test. I believe I've worked on a late model GDI, and G backed me up on this, where you've seen that on the scan tool. I can't remember which model it was.
Yeah.
But I saw that pit for, and is that a fuel pit? Is
Well,
that
power
fuel
balance, that's a great point, Dave.
Not power balance, not injector balance, but it was cylinder contribution. I
Yeah.
was looking at variations in the crankshaft.
Yeah.
But not necessarily, you were looking at just the fuel. As the
That's what
fuel
we're looking here,
pressure
strictly
dropped
at the
with
fuel.
each injector pulsing.
Right, because the cylinder contribution or the power balance test, whichever one that happens to be labeled as, is just telling me what that something is not contributing its fair share, not what. Yeah. And say your diesel example, one thing I like to do is I can do a relative compression test on the diesel. I can get a good idea if the compression's okay. It's a compression ignition engine. If there's a power balance issue, there's only one other factor left, right? So. Yeah. But on a gasoline engine like we're dealing with here, the GDIs, it still could be either one, but it's still a pointer. And I want to stress too, relative compression, that's purely mechanical, guys. Purely an issue for sealing and compression, nothing to do with fuel or spark. So that's one way to help separate that. If I know that, look at power balance, that takes one of the three out of the equation, right? But there are some manufacturers, Ford for sure I know, has an injector balance and leak down test in their scan tool. And again, most of the aftermarket scan tools are able to duplicate many of these features. So don't forget to look in your scan tools. Usually it's under what's called a service functions menu. Snap-on does a pretty good job of putting that right in that forefront in your face. Makes it easy. Others, not so much. You got to do a little digging. But you may find that test already built into your tool, and that's a big time saver. And then finally, a tip I learned from my Obi-Wan is to use your 5-gas analyzer, if you have one, to look for that leaky injector. You just pull the plugs and you stick your probe in the cylinders, and if one starts beating off like it's got a bunch of HC pouring out of it, hey, that's fuel. That's a good giveaway right there.
Don't forget, don't crank the motor with the probe in the motor.
Yeah, don't crank the motor with the probe in the motor. That would be bad. This we kind of already hit on, so just again, recap real quick. The piezoelectric GDI injectors, if you can see it, there's actually a code on the side of this injectors, that two sets of 3-digit numbers right there. So when you replace this injector or use this injector on the engine, you got to tell the computer you put that one in. You got to enter that code. And that's because they are coded for their flow rates. It's just like sticking the wrong injector in the wrong hole if you don't. And if you don't make that coding issue, you're going to have fueling issues. You're going to have drivability issues, and it's going to be very difficult to trace it down to that. It really comes to the point where that's the only thing left, which we talked about. Eliminate everything else. The only thing that's left got to be what it is, no matter how improbable it might seem to be.
Write those numbers down or take a picture of them and make sure all injectors go in order on a PCO setup.
Yeah. Now, before we go to the car, I do have a few things we want to try to show you real quick before we call it a night. And it's kind of gone on longer than I originally thought we would, but we don't want to leave you hanging in anything. If you have any questions, go ahead and let's answer a few of those now. And then we'll go ahead and do a few things on the car. So while you wait for that, we'll switch over to scope mode.
It's in mode 6, as Wilson said.
Mode injector flow?
No, not injector.
Oh.
Or injector balance per bank. Yeah, you just seen it. It's right. It is in mode 6, and some actually have it on 6.
Yeah, and but that's the key, right? It's injector balance per bank. So it could help you narrow down an issue, but it still comes to the individual whole, right? All right. Any other questions coming up?
No.
Okay, so let's go ahead and get started. We're going to start first because I've already got the vehicle set up. Again, as Dave mentioned earlier, this is a Honda that we're working on. We're going to do a relative compression test first because I've already got the injectors disconnected, disabled, so we can crank it without it starting. And I want you to take a look at the scope screen here that I've got displayed. And we'll just talk about a few things first. If you're new to scopes, set your scope up in the beginning using what I call the 20-20 rule. The 20-20 rule is very simple. I'm going to set the voltage scaling, which is the x-axis, to read 20 volts across the scale. Why? Because most of the things I'm measuring are 12-volt system. So I'll probably be in a good range there. I'll start with that. The other 20 is up here at the top, and that's my time. That's the y-axis. 20 milliseconds per division.
I think it's backwards, but you're on the right track.
Okay.
Is it Y is up and down voltage and X is across?
The X is up and down, Y is across.
That's the audience.
Ask the audience.
I'm
You're getting
thinking
some comments.
Voltage vertical,
Yeah.
time horizontal.
That's a comment.
How's that?
Yeah.
We'll do it that way.
Intended.
X1.
But 20 milliseconds, guys, that's 200 milliseconds across the screen, 10 divisions on the screen.
Right.
That's roughly the amount of time it takes for an engine to go through one 720-degree cycle at idle, warmed up. Okay, so we start there. Now, we're doing a cranking test. Not going to turn over that fast. Need more time. So I'm going to put some more time on the screen. We're just going to adjust that and say, you know what? I'm going to set that up. Let's say 500 milliseconds per division. That's going to give me a few seconds across the screen. Now, the next thing I like to do is set up a trigger. As Dave pointed out, we do a lot of things kind of by ourselves. So it's only us there. So one of my favorites is setting up a single. So we'll set that up as a single trigger. We'll set that up as a...
You should say you're on Pico 7.
Yes, I am using a Pico 7 scope, which is a pretty friendly user scope. And then we have where it's going to start. That's the little trigger part there. We're going to give that about a 10% and set that up just under the open circuit voltage that we have right now. Because what I want to do here, guys, we saw that inrush voltage that we talked about earlier. So that's what we're setting this up here to see is that inrush voltage. And we know that's going to drop significantly less. So the way we have it set up right now, we should be able to capture a pattern when we crank the engine over. So Dave, you want to do the honors and crank her over? Can you get through there without?
Yeah, but I think, are the injectors unplugged now?
Yes.
Okay.
Yes, so you should be able to start it without, or crank it rather, without a problem. And let's see if we get a pattern. All right, you can stop. Okay, now Dave kind of hesitated there. That's okay. So
Yeah,
you've got,
they're a little different. A lot of them, you hit that power button, smart power button, start button, and they just keep cranking on their own
yes.
until they start. On the Honda, I released and it stopped cranking. So every vehicle's a little different. So you want me to do it again from the start?
No, we'll be all right.
All right.
Let's see, I just,
you see a pattern. You gotta blow that out so you saved it. By the way, he showed you how to set it up with his preferred method. This is what I do personally by default. If the scope I'm using, the Pico, is good at this, and others are like this, well, they have an auto pattern set up where you go to pick out a pattern from and I'm not as familiar with the 7 I am with the 6, but in the not a library, that's stored patterns from other people who have contributed their patterns that they've caught off of good vehicles and vehicles with problems. But the sample patterns where it automatically does a setup of the time and the volts. I said X and Y, you said Y and X, whatever.
Yes.
It doesn't matter. This is volts or amps, and this is time, right?
yeah.
And that volts or amps could be, current, could be voltage, it could actually pressure or something else, temperature, whatever you're looking at. That's amplitude versus time.
Yeah.
So we have a pattern now. So was that the starter inrush?
That's the inrush.
Pattern. Okay.
Yeah, that's the inrush voltage.
So you probably want to spread that out to see those each of those contributions of current.
Yeah.
Are we on voltage? You're on voltage.
Yes, we're on
So
voltage.
you're not looking at the amp.
So we haven't looked at that yet, but
What if
we'll
the
tighten that up.
Spike of voltage going down.
Let's see if we can tighten that up.
So the 12 volts down to 10 or whatever we saw, and it actually spiked down lower, but it didn't go roar like it would if it was truly low voltage, like a dead battery or loose cables, or a really cold day, because it's good temperature in here. We got a good battery, but it did drop down way more than initially we thought it would. But you might have caught that on an old analog voltmeter, like a VAT, but it wouldn't be on anything digital since then. But on the scope, it's real time. We saw it jump way down. So that's down to what?
About 8 volts.
but then we were cranking at about what, 11 volts.
Yeah, and what we're going to share, all I did was I took the pattern, I put a low pass filter on it to kind of clean up some of the noise, and then zoomed in a little bit. What we're looking again is the valleys. That's the voltage drop. And we're looking for uniformity. Are they all dropping about the same? If there was one that was dropping less, then that would indicate that we have a weak cylinder. I wanted to show this one first because maybe you don't have a high amp clamp. You can still do this test. You want to see it even more cleanly? Then use what's called the AC coupling feature of your scope. You take the DC component out. I'm not going to measure exactly how much voltage was there, but I don't care, do I? I'm interested in the change in voltage, and the AC coupling will allow me to do that.
Current. It's going up and down.
Right, and so that will help me do that. Now, let's just say that we had a problem. And we're going to clean that back out again.
Take a spark plug out.
Nah, we have to do all that.
Yeah, remember, it has to be a mechanical problem, not fuel or spark related.
If you had a hole in the cylinder, a hole in the block, a hole in the head, a big head gap, a valve that was burnt terribly, you would see that.
Right.
And you wouldn't have to pull the spark plugs out to use a gauge. If you wanted to test this at your shop for the first time, your school, whoever's watching, right? You want to check out the first time and go, hey, I'm not so sure about this. You know, I've heard about this, but I want to just take one spark plug out and do the same test with the bolts, and as we'll see next with the amps.
Yeah, well, so you'll see too, and like you said, you'll be able to see what it looks like.
If it ran, it'd sound like a John Deere. Boop, 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 boop.
Yep. And I'll tell you that I found cylinders with as little as 10-15% variance in compression using this method.
With the voltage.
Yeah, so and that's pretty darn good. So now if we have a problem, then we put out a second channel. The second channel is going to be our landmark, our reference. All I did was I just pick an easy coil to get to. These are coil unplug ignition system, 3-wire system. So on those, that third wire is actually the trigger signal from the ECM. The igniter itself now is built into the coil, correct? So I'm not going to see that firing line like we could on the older 2-wire coils, and certainly on anything with a wire. But that's okay. That's still telling me when the ignition event is supposed to occur, right? So we've got that all. It was all set up. I've already got it turned on. So Dave, you'd be so kind as to crank it again and just keep it cranking. And we'll fill the screen up. Like I said, if it were only Dave here in the shop by himself, he'd be able to do this by himself. All right, got the pattern. We're all good. And yes, we did. So, okay, so now we'll go back in again. I'm going to do the same thing with the filtration. That's on. We're going to put the same thing on the number 2.
And if you want to save some time, you're working by yourself, don't forget tricks like if the scan tool has the ability, the scan tool you have, to crank the engine. I've used that on some tests when I'm doing development in the shop. Like I don't have the assistant, and I really want to watch something and not have to run over to the vehicle. Yeah. If the vehicle lets the scan tool crank it, use that scanner to do that.
So now what we've done is we've overlaid the ignition event onto that voltage pattern that we just looked at. That's giving us a reference. That tells us where we are in relation in the forest to the trees, right? So we can actually, well, that's zoomed up pretty good. I want you to look at what does that do? That's intersecting that base, isn't it? That's intersecting that base, isn't it? That intersects that base, isn't it? When does the ignition event occur? Just before top dead center. Where is the drop occurring? Top dead center compression, right? That's the maximum pressure that starter is trying to overcome. Is this a dead weight to know for sure? Yes. It tells me the ignition timing is okay. If it was seriously out of whack, then I would see it shifted one way or the other from that peak.
Blow that up a little bit?
Yeah, sure. Let's blow that up and we'll take a good look at it. Yep. Now you can see it even better. And there's that ignition trigger. That's ECM telling the coil to fire, and it's putting right there at the base. So that tells me that I'm in pretty good shape in terms of when the ignition is actually occurring, right? And then the last thing we wanted to do as a comparison, we'll get rid of that for now, and we're going to add a current clamp. And we'll see, we'll pick that up.
Because sometimes I'm a slow learner, And I'm sure there's a few people that go, dude, slow down a little bit. I'm a slow learner. I'm watching right now. And Pete, correct me if I'm wrong. These major dips, not the spikes, these major dips are the voltage.
Yes.
This is just some artifacts.
Absolutely. The little fuzz you see is just noise.
So when you blew that up and we saw that ignition interface when that happened, that wasn't like looking at a couple of voltage drops. That was looking at this voltage drop.
Right. Looking at the base.
Cylinder on TDC right there.
Yeah, looking at the base. That's what we're interested in.
Because if I understand it, I know all you guys and gals can as well.
So let's see. We'll get that on. And we'll just reach over here and turn the clamp on real quick. Again, we're using a 600 amp clamp. It's just, you can use it on the negative or positive battery cable as long as you go around all the cables. Okay, that's the thing. Now we'll go ahead and start our scope up again. Ask the maestro to crank her over. All right, and we stop. And then we'll take a look at what we got here. Let's see, we'll put, just for fun, we'll put the filter there. I'm going to draw that current down a little bit. Now, this is why a lot of guys like the current more so than the voltage, because the peaks are so much easier to see. And I'm going to tell you right now, guys, this is current being taken by the starter motor. This is actually a negative number. To be technically correct, it would be the other way around. It would be going downhill. But we've been doing it like this for so long. It's kind of the accepted way. And we just notice things better when it's oriented this way. We can see the peaks compared to the valleys. But what I wanted to share with you here is, let's see what happens when we turn that voltage around. And we'll see, William, to zoom in on that so we can see it better. Now, well, you can see that, but do you see how now that peak is actually the voltage drop? We've just inverted the pattern. But see how it corresponds to the pattern above it? So just driving home, you're getting similar results no matter whether you're using the voltage or the current.
Right.
You can do this. You can do this. In fact, if you're a new scope guy, folks at AES Wave has a little pocket-sized one-channel scope, very powerful little scope, the U scope, and it works great. You can perform this and many of the other tests using that tool just fine.
I personally have done this test as well as the fuel pump current waveform. Current ramping fuel pumps with the one-channel U scope.
Yeah, absolutely. You can do the same thing.
Yep.
Right. Yep, there we go. She's got one right here.
We're going to be doing a webinar on that on Lunch and Learn.
All right.
Wednesday.
Not anymore.
No, but and I think like and it's a very affordable scope, you know, for getting it started.
Yeah. So you got cargo pockets. It's already with you. The other cargo pockets for the leads.
It's good to practice with at home because you can get a little sense of simulator.
Oh, that's right.
Oh yeah.
And
So you don't have to go work on a car and go get a simulator. They're dirt cheap. You can get stuff off of Amazon. I've done it. You know, little circuit waveform generator, things like that. Nothing expensive. What, $10, $20 and a 9-volt battery. You're playing with stuff at home, you know, on your workbench or the coffee table. If it's okay with your better half, all right. Put a fender cover down or a kitchen table, whatever you do. But get scoping. That helps you with coping.
that definitely is a good thing to practice.
All right. So I think we got about everything covered that we're going to get covered tonight. Again, want to ask one more question. First, we got to give a big thank you once more time to Delphi, not only for sponsoring tonight's webinar, but also for allowing Dave, their senior curriculum developer and trainer. He's been with them for many, many years, travels all around the world, training everybody from technicians like you guys and gals to engineers at the manufacturers. So he knows of what he speaks. He's a great resource for you to keep in your little Rolodex if you have questions on anything that comes related to engine management, fuel delivery, HV, EV, PDC, PC, everything else. This is the man.
Every
Other man, right? And I would be absolutely remiss if I didn't make sure that and I'm going to let G do all the main of the talking on this, but what I do want to say is I'm very proud to be a part of what will be TST's 20th anniversary big event.
Oh, really?
So G, tell us all about that as well.
Okay, so TST, excuse my voice and everything here. TST big event, March 18th, 2023. It's our 20th year. And for 20 years, myself, Doreen, Pierre, Eric, and a few others have really helped out to bring education to all the different techs that maybe can't really afford it. It's at an affordable price. And this year, not only like I guess in the past 5 years, everyone's getting an Android tablet again. We have a hot breakfast, hot lunch, and a special after party this year where you could win some great prizes, some cash, and mingle. There'll be hot food, some drinks, mingle with the vendors, check out the different instructors. You can bend our ears. And of course, we'll have 2 great instructors this year. We have Keith Perkins coming out and Gary Smith, and a very surprise special mystery instructor, and our buddy Peter Cole. And who's going to be the keynote speaker? Well, the character to my left will be the keynote speaker.
I was voluntold.
He was voluntold.
Yeah. But no, I'm looking forward to it. Like I said, it's been, and guys, I don't want to sound mushy. It's been my sincere honor and pleasure to have met and connected with the folks here at TST, specifically G, Pierre, Doreen, who didn't know me from Adam 12 years ago. Probably the first webinar we did, he's looking at me going like, who the hell is this guy? This ain't going to last. But we share a common goal as well as Dave does. We do this primarily because we want to do something for you guys to make your job easier in dealing with these technical challenges that you have today. There's never been a more challenging time for technicians than now. No more exciting time than for technicians than now, because you guys are on the brink of changes in the automotive industry that are just beyond comprehension. A lot of exciting things to come, but you got to keep up. To keep up, was it how you say? Of update or evaporate, for sure. I love his little acronyms. But again, I want to give a real big shout out because these guys, they're not getting paid. They're here on their own, making the use of his facilities and helping me help you. And for that, I want to make sure that you give them some love. And if you can make that be a big event, by all means do so. I promise you, it's one of those bucket list events that you will never forget attending. I can tell you that for sure.
Where is it again? It is in Terrytown, New York at the Marriott Hotel. Sign up early. There's 550 all table seats. So once they're sold out, they're sold out. People have been buying them. Go to www.tstseminars.org. That's tstseminars.org. And let's not forget this Wednesday night, we have the Jeff Zeidman. You own a lab scope from ATS, but even if you don't, this guy is phenomenal. Even though he pots the cars and he potties, he's originally from Massachusetts. He does a great job, Jeff. He's the head hotline guy for ATS. Pierre does some stuff. Once in a blue moon, you may get me. But Jeff really knows the stuff. He puts together a very good class. This will be his second time back. And let's not forget in December, we got the great Bernie Thompson coming out.
Really?
Yes, Bernie just confirmed the other day.
Awesome.
He has a great class he's putting together. And we also have in January, John Thornton.
Wow.
I was just with John in PA. Other names, Scott Mann will be there, Kenny Zanders. These will be other instructors coming up for the rest of the year. Our year goes September all the way out until June, and then we do a couple of round tables. So please don't forget, go to tstseminars.org, sign up. And Dave, I want to thank you again and Delphi for having you come out. Sorry I couldn't participate much more than I did. And thank all of you, because without you, I guess Pete and I wouldn't be here doing it in the first place.
Yeah. So again, guys, and one last thing I'd like to ask in closing, thank you so much for sticking out here with us. We see that a lot of you guys have been online the whole time with us, and we appreciate that. We hope that you leave here tonight with a little bit more than you came here with. If your time was not wasted tonight, if you felt that tonight was worth hanging out with us tonight, do me a favor, throw us up a Y in the chat. Let us know what you think. If you think that, I could have been better off watching the ball game or something, or whatever might be going on, then typing an N. So we'll give you a few minutes to do that. Ask any other questions that you might have, and then we'll wind down.
And we want to say thank everyone again, not only for coming out, but we want to say happy Thanksgiving.
Absolutely.
Next week to you and your family. God bless all of you. God bless our great country here. And since we won't see them for a TST Motor Age webinar, Merry Christmas, Happy Hanukkah, Happy Kwanzaa, and Happy New Year to you and yours.
Absolutely. Absolutely. All right.
A lot of thank yous and a happy belated birthday to Dave.
All right.
Look at that. Facebook. I did that.
All right. So again, ladies and gentlemen, thank you so much for coming out. We will be back in January, so stay tuned for that. You now have your account. If you're new to Motor Age training, avail yourself of that library. There are a lot of good stuff there to help you out. Take full advantage of it. That's what it's there for. And I guess until then, guys, thank you so much. Y'all have a great night. Good night.
Good night.
Good night.
It's got to go through, right? Does it go through anyway?
Good job, guys. Good job.
There we go.